Hello, take a deep breath, exhale slowly, and let your body completely relax on your soft bed. In the gentle darkness of the room, what do you feel? Perhaps it's the stillness of the night, the steady beat of your heart, or the solid feeling of the ground beneath you. Everything seems to be standing still, an absolute and peaceful stillness. And yet, behind that stillness lies a magnificent truth that our minds can sometimes hardly imagine. Right now, as you prepare to drift off to sleep, you are actually on a giant spaceship called Earth, hurtling through the void at a speed that no race plane or supercar could ever touch. Imagine you are standing on our planet's equator. At that very spot, the Earth is spinning on its axis at a speed of about 1,040 miles per hour. A colossal number, isn't it? It's faster than the speed of sound. If you were in a car going about 60 miles an hour, you'd feel the wind rushing past your ears and the vibration of the engine. And yet, at a speed more than 16 times that, why don't we feel the slightest shake, the slightest draft, or any sign of movement at all? The answer lies in the magic of nature and the way the human body is designed to perceive the world. Think back to a time you were on a large airliner. Once the plane reaches a stable altitude and flies at a steady speed of about 560 miles per hour, if you close your eyes, you'd feel as if you were sitting in your own living room at home. The glass of water on your tray table doesn't ripple, the newspaper you're reading doesn't tremble. You only feel the motion when the plane changes velocity, when it accelerates for takeoff or brakes for landing, or when it passes through a patch of turbulence. Our Earth is just like that, only it's the most perfect aircraft that has ever existed. It spins at an incredibly stable speed, never suddenly accelerating and never slamming on the brakes. This absolute consistency completely fools our senses, creating an artificial yet incredibly pleasant sensation of stillness. But this stillness doesn't just come from the constant velocity. It also comes from the fact that everything around you is performing this dance together. Imagine the atmosphere, the clouds, the mountains, the vast oceans, and even the house you're in. All of it is spinning at the same speed as the ground beneath your feet. There's nothing standing still to serve as a reference point, so there's no opposing wind to tell you about that incredible speed. We are like passengers inside a sealed, velvet-lined train car, where the air inside also moves along with the car. In this chapter, we will begin to gently touch upon the first concepts of cosmic motion. Did you know scientists at the National Aeronautics and Space Administration, commonly known as NASA, have spent decades observing and measuring this rotation from space stations? They see the Earth as a sparkling blue marble, spinning rhythmically against the deep black backdrop of the universe. For the astronauts on the Apollo missions in the past, or for those working on the International Space Station today, the Earth's rotation is a tangible reality right before their eyes. They see continents glide by beneath them. They see the line between day and night constantly moving. But for us, curled up in our warm blankets, that motion becomes gentle and cleverly hidden. The stillness you're feeling is truly a gift from the universe. Just think, if we could feel every tiny vibration of the planet, how chaotic life would be. Instead, nature has gifted us a stable environment in which to survive, to dream, and to sleep soundly. The Earth's rotation not only creates the rhythm of day and night, giving us time to rest, but it also generates invisible forces that protect life. As you sink deeper into relaxation, let the idea of this rotation soothe you. You are not standing still. You are traveling. Every second that passes, you travel nearly a third of a mile through space without any effort at all. It is the smoothest and most effortless journey you will ever take. Our planet, with its enormous mass of 6 sextillion tons, is cradling you in its arms, spinning steadily, relentlessly, for billions of years. Gradually, let these numbers and scientific concepts become a steady rhythm in your mind. 1,040 miles per hour. That is the speed of life, the speed of a planet at work, creating dawns and sunsets. But right now, the only speed you need to be concerned with is the slow rhythm of your own breath. The stillness around you is real, because within the frame of reference of this room, of this bed, you are in a state of absolute rest. We will close this opening chapter here with a new understanding of the world. You are on a planet in constant motion, yet you are always safe and at peace. In the next chapter, we will delve deeper into this giant vessel and find out why the atmosphere doesn't leave us behind as the Earth spins so quickly. Chapter 2: The Smooth Ride of the Cosmos. We've just explored the first visualizations of this planet's incredible rotational speed, about 1,040 miles per hour at the equator, a number staggering enough to daze anyone if we could actually feel it in our bones. And yet, why is everything around you so peaceful? Why doesn't the glass of water on the table tremble? And why can you lie here quietly, listening to these words, without feeling like you're being flung into space? To understand this, we need to step aboard an imaginary train, together the most extraordinary train ever built by humankind. Imagine you are sitting in an incredibly luxurious, first-class train car. This car is lined with soft velvet cushions, lit by a gentle golden light, and completely soundproofed from the outside world. The train begins to leave the station. At first, as it accelerates, you'll feel your back pressed lightly into your seat. That is a change in velocity. But when the train reaches a constant velocity, say 180 miles per hour, and moves on a perfectly straight, flawless track with no bumps or curves, what happens? If you close your eyes, you would no longer know you were moving. You could leisurely pour a cup of tea, and the stream of water would fall perfectly straight into the cup, not deviating by a hair's breadth. Our Earth is just like that perfect train car, but on a scale millions of times grander. The most important reason we don't feel ourselves spinning is because the Earth's speed is a constant velocity. In physics, humans have no sensory organs to measure absolute velocity. We can only perceive changes in velocity, otherwise known as acceleration or deceleration. When you're in a car and the driver suddenly hits the brakes, your body is thrown forward. When the car takes a sharp turn, you feel a force pushing you to the side. That's when the sensors in your inner ear, the place that maintains your body's balance, sound the alarm. But the Earth is different. It never hits the brakes, never suddenly accelerates, or makes an unexpected turn. It spins persistently, steadily, revolution after revolution, for billions of years. It is this absolute stability that creates the illusion of being stationary. We were born on this vessel. We grew up on it. And every cell in our bodies has been completely synchronized with its velocity since we were tiny specks of life. To your body, the Earth's state of constant rotation is its natural state of rest. Think of a more practical example you may have experienced. Sitting on a large airplane as it flies at an altitude of 33,000 feet. When the plane is cruising, if the pilot didn't make an announcement and you weren't looking out the window to see the clouds drift by, you would feel as if you were in a stationary room on the ground. You can even walk leisurely down the aisle. Why aren't you thrown toward the back of the plane when it's flying at 560 miles per hour? It's because you, the air inside the plane, and all the objects within it are moving along with the aircraft. There is no difference in velocity between you and your immediate surroundings. Applying this to a planetary scale, we find that it's not just the ground that's spinning, but the entire atmosphere surrounding us is spinning with it. You can imagine the atmosphere as a thick, soft jacket wrapped around the planet. This jacket isn't left behind as the Earth turns. It's held tightly by gravity and rotates in the same rhythm. If the atmosphere didn't spin with the Earth, we would have to endure winds with speeds of thousands of miles per hour sweeping across the surface, flattening everything. But no, this miraculous synchronization makes everything around us seem still. The blade of grass outside doesn't stir unless a local breeze passes by, and the surface of the lake remains perfectly calm, reflecting the peaceful moonlight. Các nhà khoa học vĩ đại trong lịch sử như Galileo đã từng giải thích điều này bằng một thí nghiệm tưởng tượng về một con tàu thủy. Ông nói rằng, nếu bạn ở trong một căn buồng dưới hầm tàu của một con tàu lớn đang chuyển động đều trên mặt biển êm ốc mà, bạn sẽ không thể thực hiện bất kỳ thí nghiệm nào để biết tàu đang chảy hay đang đứng yên. Những giọt nước từ bình cổ cong vẫn rơi thẳng xuống chai bên dưới, những con bướm vẫn bay lượn tự do trong phòng mà không bị dồn về phía đuôi tàu. Trái đất chính là con tàu của Galileo trôi đi giữa đại dương vũ trụ bao la. Sự tĩnh lặng này còn được củng cố bởi một yếu tố về kích thước. Trái đất rất lớn, cực kỳ lớn so với cơ thể nhỏ bé của con người. Mặc dù tốc độ quay tính theo km/h là rất nhanh, nhưng nếu chúng ta tính theo số vòng quay, bạn sẽ thấy nó chậm đến mức nào. Trái đất mất đúng 24 giờ để hoàn thành một vòng quay quanh trục của mình. Hãy tưởng tượng một chiếc kim giờ trên đồng hồ của bạn. Nó quay một vòng mất 12 giờ. Tức là nó còn quay nhanh gấp đôi so với hành tinh của chúng ta. Khi một vật thể khổng lồ quay chậm rãi như vậy, lực ly tâm, cái lực cố gắng hất mọi thứ ra ngoài khi quay tròn, trở nên rất yếu so với sức hút nghìn nghịt của trọng lực hướng vào tâm. Chính vì vậy, ngay cả khi bạn đang lao đi trong không gian với vận tốc của một viên đạn, bạn vẫn cảm nhận được sự bình yên tuyệt đối. Sự đứng yên mà bạn đang cảm nhận không phải là một sự lười biếng của vũ trụ, mà là kết quả của một sự vận động cực kỳ tinh vi và nhịp nhàng. Nó giống như việc bạn đang được bế trên tay một người khổng lồ, đang sải bước rất nhanh nhưng vô cùng êm ái, đến mức bạn không hề thức giấc. Mỗi khi bạn cảm thấy cuộc sống quá xô bồ và hối hả, hãy nhớ rằng ngay cả khi bạn ngồi I am, bạn vẫn đang là một phần của một hành trình vĩ đại. Bạn đang lướt đi trong không trung, vượt qua những khoảng cách hàng nghìn km mỗi giờ mà không cần tốn một chút tâm sức nào. Sự tĩnh lặng quanh bạn là một chứng minh cho sự hoàn hảo của các định luật vật lý, cho thấy vũ trụ đã được sắp đặt một cách tài tình để nâng đỡ sự sống. Chúng ta vừa hiểu ra rằng chính sự đều đặn của vận tốc và sự đồng bộ của mọi thứ xung quanh đã tạo nên cảm giác đứng yên. Nhưng có một lực lượng quan trọng mà tôi vừa nhắc đến, một sợi dây vô hình nhưng vô cùng mạnh mẽ, giữ cho bạn không bị văng ra khỏi chuyến tàu tốc hành này, và cũng giữ cho bầu không khí luôn kề cận bên ta. Đó chính là trọng lực. Ở chương tiếp theo, chúng ta sẽ cùng khám phá sâu hơn về chiếc trắng ấm khí quyển và cách mà trọng lực đã đóng vai trò như một người quản gia tận tụy, giữ cho mọi thứ trên bề mặt trái đất luôn ở đúng vị trí của nó, bất chấp vòng quay điên cuồng của hành tinh giữa hư không. Mọi thứ đang kết nối với nhau một cách chặt chẽ, và chúng ta sẽ cùng tìm hiểu về lớp bảo vệ vô hình ấy, thứ đang giúp bạn có một không gian thật yên ổn để nghỉ ngơi vào lúc này. Hay để tâm trí bạn tiếp tục trôi bồng bềnh theo nhịp quay đều đặn của hành tinh. Trong khi chúng ta cùng nhau khám phá một bí ẩn tiếp theo, bạn có bao giờ tự hỏi, nếu trái đất đang lao đi với tốc độ hơn 1.600 km/h, tại sao mái tóc của chúng ta không bị thổi tung lên? Tại sao những lá thư trên bàn không bị cuốn bay đi bởi một cơn cuồng phong vĩnh cửu? Câu trả lời nằm ở một thực thể vô hình nhưng vô cùng mạnh mẽ, một lớp màng bảo vệ dịu dàng mà chúng ta gọi là bầu khí quyển. Chương 3. Bầu khí quyển, chiếc trăng ấm bao bọc. Trong những chương trước, chúng ta đã ví trái đất như một chuyến tàu êm ái, nhưng hãy tưởng tượng một kịch bản khác. Bạn đang ngồi trên một chiếc xe mui trần, chạy với tốc độ chỉ 100 km/h. Ngay lập tức, gió sẽ tạt mạnh vào mặt bạn, tiếng ù ù của không khí sẽ lấp đầy màng nhĩ, và mọi thứ không được giữ chặt sẽ bị hất văng ra phía sau. Đó là vì chiếc xe đang chuyển động xuyên qua khối không khí đứng yên, nhưng trái đất của chúng ta lại không hoạt động theo cách đó. Trái đất không chạy xuyên qua không khí, nó mang theo toàn bộ bầu không khí cùng đi với mình trong chuyến hành trình xuyên vũ trụ. Bầu khí quyển của chúng ta không phải là một thực thể tách biệt, lang thang bên ngoài bề mặt hành tinh. Nó giống như một lớp vỏ mềm mại, bám chặt lấy lớp vỏ đá cứng bên dưới. Hãy tưởng tượng bạn đang cầm một quả cam vừa mới rửa. Nước vẫn còn đọng lại trên vỏ. Khi bạn xoay quả cam một cách chậm rãi, lớp nước mỏng đó sẽ xoay theo quả cam. Bầu khí quyển cũng vậy, nhờ có lực ma sát và đặc biệt là trọng lực, toàn bộ khối không khí khổng lồ bao quanh chúng ta, từ những tầng thấp nhất, nơi chúng ta hít thở, cho đến những tầng cao nhất, nơi các vệ tinh hoạt động, đều đang cùng thực hiện một điều nhảy đồng bộ với mặt đất. Nếu trái đất là một quả bóng đá, thì toàn bộ bầu khí quyển mà chúng ta có thể hít thở chỉ mỏng manh như một lớp sơn phủ lên bề mặt quả bóng đó. Mặc dù mỏng so với kích thước khổng lồ của hành tinh, nhưng nó có khối lượng lên tới khoảng 5 triệu tỷ tấn. Một khối lượng khổng lồ như vậy luôn bị sức hút của trái đất níu giữ. Khi trái đất quay từ Tây sang Đông, sức hút này kéo theo bầu khí quyển quay cùng theo. Chính vì thế, khi bạn đứng trên mặt đất, bạn và khối không khí xung quanh bạn đang chuyển động cùng một vận tốc. Không có sự chênh lệch về tốc độ, nên không có gió vũ trụ nào thổi qua. Mọi thứ trở nên tĩnh lặng một cách kỳ diệu. Hãy thử tưởng tượng một điều khủng khiếp hơn để chúng ta thấy trân trọng sự tĩnh lặng này. Nếu vì một lý do thần kỳ nào đó, trái đất đột ngột dừng quay, nhưng bầu khí quyển vẫn tiếp tục chuyển động theo quán tính, lúc đó không khí sẽ tràn qua bề mặt hành tinh với tốc độ hơn 1.600 km/h. Cơn gió đó sẽ mạnh gấp nhiều lần những cơn bão mạnh nhất từng được ghi lại trong lịch sử nhân loại. Nó sẽ cuốn bay các đại dương, san phẳng những dãy núi hùng vĩ như dãy Hima, Láp Sơn và xé nát mọi công trình nhân tạo. Nhưng sự thật là điều đó không bao giờ xảy ra. Bầu khí quyển và mặt đất đã gắn kết với nhau như một đôi tình nhân bền chặt suốt hàng tỷ năm qua. Các nhà khoa học tại các tổ chức như Cơ quan Vũ trụ châu Âu hay thông qua các hình ảnh từ kính thiên văn không gian Hubble đã cho chúng ta thấy rõ sự gắn kết này. Khi nhìn từ xa, bầu khí quyển hiện ra như một dải lụa màu xanh lơ mỏng manh bao quanh trái đất. Dải lụa ấy không hề bị tuột khỏi hành tinh dù chúng ta đang xoay tròn. Thậm chí, khi quan sát các hành tinh khác như sao Mộc, chúng ta thấy những dải mây khổng lồ cũng đang quay cuồng cùng với hành tinh đó, tạo nên những quy luật thời tiết riêng biệt. Sự quay đồng bộ này còn mang lại cho chúng ta một lợi ích tuyệt vời khác. Nó giúp giữ ấm cho hành tinh. Bầu khí quyển giống như một chiếc chăn ấm áp bao bọc lấy trái đất. Nếu không có nó, mặt hướng về phía mặt trời sẽ nóng bỏng đến mức thiêu cháy mọi thứ, trong khi mặt quay đi sẽ lạnh giá đến mức đóng băng tất cả. Nhờ có sự chuyển động cùng nhau, bầu khí quyển giúp điều hòa nhiệt độ, tạo ra một môi trường sống ổn định mà bạn đang cảm nhận ngay lúc này. Hơi ấm dưới lớp chăn của bạn, sự tĩnh lặng trong căn phòng này, tất cả đều là nhờ bầu khí quyển đang làm tròn nhiệm vụ của mình. Bạn hãy thả lỏng cơ thể hơn nữa. Hãy cảm nhận lớp không khí xung quanh mình. Nó thật nhẹ nhàng, thật dịu êm. Lớp không khí ấy đang ôm lấy bạn, cùng bạn bay xuyên không gian. Bạn không cần phải làm gì cả, không cần phải bám víu vào đâu, vì bầu khí quyển đã bao bọc lấy bạn trong sự che chở tuyệt đối. Nó giống như một người mẹ đang bế đứa con trên tay khi đang đi bộ. Đứa trẻ sẽ không cảm thấy sức gió thổi vào mặt vì nó nằm gọn trong lòng mẹ, cùng di chuyển với tốc độ của mẹ. Có một điều thú vị mà các phi hành gia trên trạm vũ trụ quốc tế thường kể lại. Khi họ nhìn xuống trái đất, họ thấy những đám mây trắng muốt trôi lững lờ trên những đại dương xanh thẳm. Những đám mây ấy có vẻ như đang di chuyển rất chậm, nhưng thực tế, chúng đang lao đi với tốc độ hàng nghìn km trên một giờ cùng với toàn bộ hành tinh. Mọi sự vận động trong vũ trụ đều mang tính tương đối. Đối với một người quan sát từ bên ngoài, chúng ta đang di chuyển cực nhanh. Nhưng đối với chúng ta, những người con của trái đất, thế giới này là một nơi trốn yên bình và vững chãi. Bầu khí quyển còn đóng vai trò như một tấm lá chắn bảo vệ. Hàng ngày, có hàng triệu mảnh thiên thạch nhỏ bằng hạt cát lao vào trái đất với tốc độ cực lớn. Nếu không có chiếc chăn không khí này, chúng sẽ bắn thẳng xuống mặt đất như những viên đạn. Nhưng nhờ bầu khí quyển cũng đang quay và di chuyển cùng chúng ta, nó tạo ra một lực cản, khiến những mảnh đá thiên thạch đó bị đốt cháy do ma sát, tạo thành những vệt sao băng lấp lánh mà chúng ta đôi khi thấy trên bầu trời đêm. Sự tĩnh lặng của bạn hiện tại đã được đánh đổi bằng sự bảo vệ kiên cường của lớp không khí ngoài kia. Khi bạn hít vào một hơi thật sâu, bạn đang đưa một phần của bầu khí quyển vĩ đại đó vào trong lồng ngực mình. Một phần của sự vận động vũ trụ đang hòa quyện vào trong máu thịt của bạn. không khí trong phổi bạn, không khí trong căn phòng và không khí trên đỉnh núi Everest đều đang cùng nhau thực hiện một hành trình không mệt mỏi quanh trục của trái đất. Sự đồng nhất này chính là chìa khóa để chúng ta có thể tồn tại và cảm thấy an tâm. Tuy nhiên, bầu khí quyển không thể tự mình làm được tất cả những điều kỳ diệu đó. Nó cần một sức mạnh nền tảng hơn, một thứ quyền năng vô hình đã nhào nặng nên hình hài của vũ trụ và giữ cho mọi thứ không bị phân rã. Tại sao bầu khí quyển lại bám chặt lấy mặt đất mà không bay mất vào không gian trống rỗng? Tại sao chúng ta không bị văng ra ngoài như những giọt nước văng ra từ một chiếc lồng giặt đang quay? That is when we need to mention the great guardian of Earth, an invisible bond, yet stronger than any steel in the world. That power is always present beside you, right beneath your back, keeping you peacefully on this warm bed no matter how fast the planet spins. That power is gravity. We will gradually move on to a new concept, where the planet's pull becomes the focal point of the story. Just lie there and let the stillness of the atmosphere continue to soothe you. We are about to learn about the invisible thread that has connected all of us, turning the Earth into a stable home in the heart of the vast universe. As you are lying here, completely relaxing your muscles and letting your breath slow down, something magical is happening that we perhaps often take for granted. You feel that you are being supported. The bed, the floor, and deeper still, the rock and soil of the planet are holding you. You are not floating. You are not drifting away. There is a silent, persistent, and incredibly powerful force at work every second, every minute, ensuring that no matter how fast the Earth spins, you remain right where you belong. That force is gravity, the invisible thread connecting every heart and every atom on this planet. Chapter 4. Gravity, the invisible thread. Imagine you are standing on a giant carousel at an amusement park. As the carousel begins to spin faster, you feel a force pushing you outward, as if trying to fling you off the ride. Scientists call that centrifugal force. With the Earth's rotational speed of over 1,600 kilometers per hour at the equator, this centrifugal force should theoretically be immense. It's strong enough to throw everything on the surface into the blackness of space. Yet, why can we walk around so calmly? Why do rivers still flow gently within their banks? And why can you lie here so peacefully? It's because the Earth has a secret weapon to keep us grounded: gravity. Gravity is like a giant, never-ending hug from Mother Earth. It is an attractive force originating from the planet's own massive weight. All objects with mass attract each other, and because the Earth is so large, its pull is unrivaled on this surface. Imagine gravity as trillions of microscopic, transparent silk threads connecting from the center of the Earth to every cell in your body, to every grain of sand on the shore, and every dewdrop on a leaf. These threads constantly pull us toward the planet's core, creating our sense of down and up. So, why don't we feel the battle between the inward pull of gravity and the outward push of rotation? The answer lies in the incredible difference between these two forces. Scientists have calculated that at the equator, where the outward push from the rotation is strongest, gravity is still about 290 times more powerful. That means the force holding you here is far greater than the force trying to push you away. The outward push of the rotation only makes you slightly lighter, an amount so small that human senses cannot perceive it at all. Without gravity, we would be flung into the universe in the blink of an eye. But thanks to this diligent guardian, that high-speed spin is just a smooth and harmless motion. Try to imagine yourself as a tiny speck of dust on a large leather ball. When the ball spins, if you are only loosely attached, you will fall off. But if there were an extremely powerful magnet inside the ball holding you tight, you would feel as if you were standing still on a stable surface, no matter how fast the ball spun. The Earth is that magnetic ball, and gravity is its eternal magnetic field. It is thanks to gravity that the atmospheric blanket we discussed in the previous chapter can cling tightly to the planet. Gravity holds the air in, preventing it from dissipating into the empty void of space. It creates a steady air pressure that envelops your body like a warm hand. This power not only keeps us on the ground, but it also shapes the world around us. Gravity pulls rainwater down, forming streams and rivers that flow to the sea. Gravity keeps the moon close to the earth, creating the rhythm of the tides. And above all, gravity gives you a sense of stability. When you close your eyes, the vestibular system in your ears uses gravity itself to tell your brain whether you are lying down or sitting up. Without this invisible thread, your brain would fall into a state of panic from disorientation. The peace you are feeling in this dark room is gravity's silent affirmation. Don't worry, I'm still holding on to you. Think about the astronauts on the International Space Station, or ISS. There, they live in an environment where gravity seems to disappear. They float, with no up and no down. Simple tasks like drinking a sip of water or getting some sleep become incredibly different. To sleep, they have to strap themselves into sleeping bags attached to the walls so they don't drift away and bump into equipment in their sleep. You are much more fortunate than they are. You have gravity as your anchor. You can release the entire weight of your body onto the mattress, knowing for certain that you will never drift away. This stability is a cosmic luxury that we often forget to be grateful for. This invisible thread also has a wonderful characteristic. It is incredibly consistent. It never tires, never suddenly weakens or strengthens. This regularity allows life to flourish. Plants can sink their roots deep into the earth because they know gravity will keep the soil there. Birds can spread their wings and fly high because they know gravity will always be the anchor to which they return. And we humans can build houses and cities that reach for the sky because we trust in the protection of this attractive force. As you lie here, try to feel the weight of your body. Your legs feel heavier, your arms feel heavier, and your whole body seems to be sinking deeper into the softness of the bed. This is when you are most clearly feeling your connection to the planet. The Earth is whispering to you through gravity that you are a part of it, that you belong here. The speed of 1,670 kilometers per hour out there can do nothing to you, because this bond is unbreakable. Gravity is not just a dry physics concept that Isaac Newton discovered under an apple tree. It is the thread of love that the universe has for us. It keeps the atmosphere from leaving, keeps the oceans from overflowing their shores, and gives our souls a place to anchor. In the silence of the dark night, let this gentle weight soothe you, guiding you into the deepest state of relaxation. But you know, the magic of not feeling the Earth spin doesn't just stop with gravity or the atmosphere. It also has to do with something related to perception and scale. Our Earth is truly massive, so large that all of its movements become vast and elusive to a tiny creature like a human. To truly understand why that high-speed rotation becomes invisible to us, we need to reconsider our own size and proportion relative to this shared home. In the next chapter, we will shrink ourselves down even further, or expand our vision even wider, to see the correlation between the small and the great. We will discover how the Earth's enormous size has tricked our senses, turning a turbulent journey through space into a peaceful afternoon nap in a green field. Everything is still in motion, but in the vastness of scale, that motion suddenly becomes incredibly gentle. Allow yourself to continue sinking deeper into relaxation as we open up a new perspective on this great shared home. You are lying there, feeling the gentle weight of your body under the influence of gravity. And now, I invite you to join me on a journey in your mind. Imagine yourself gradually shrinking, smaller than a grain of sand, so small that you are just a tiny dot on the surface of a giant blue sphere. It is at this boundary, between the infinite smallness of man and the infinite greatness of the planet, that we will find the next answer to the question, How can such a fast rotation bring about such absolute stillness? Chapter 5. Size and Scale. There is an interesting truth about human perception. We often only recognize what is within our line of sight, or is proportionally similar to us. When you stand before a giant wall, you don't see its entire shape. You only see a flat surface. Our Earth is just such a round and immense wall. With a diameter of about 12,700 kilometers and a circumference of up to about 40,000 kilometers, this planet is so large that it surpasses all abilities of the human brain to visualize in daily life. This immensity is a mask that conceals motion. To understand this, let's consider a concept that scientists call angular velocity. Do you remember the number 1,670 kilometers per hour that we mentioned? That is linear speed, the distance a point on the equator travels in a unit of time. It sounds very fast, but let's look at it from a different perspective. The Earth is a complete circle with 360 degrees. To complete a full rotation of those 360 degrees, the planet needs 24 hours. If you do a simple calculation, you'll see that in 1 hour, the Earth only rotates 15 degrees. 15 degrees is a very small angle, just a little wider than the width of 3 of your fingers held out in front of you. Try to imagine the hour hand on your clock. It makes a full circle in 12 hours, meaning its speed of rotation is twice as fast as the Earth's. Our Earth is spinning in an extremely slow and calm manner. It's because it's so large that even though it travels a great distance through space, the angle of its rotation relative to your body is too small to be felt. When you stand on the seashore and look far out to where the water meets the sky, you see a straight line we call the horizon. In reality, that horizon is slightly curved, but because the Earth is so immense, that curvature becomes invisible to the naked eye. You don't feel like you're standing on a rolling sphere because, from your tiny perspective, every direction seems to be on a stationary, flat plane. The size relationship between a human and the planet is like a tiny ant crawling on a giant, flying balloon. The ant only sees the fabric beneath its feet as flat and stable, completely unaware that the entire sphere is moving rhythmically through the air. Think about the vastness of the oceans. The Pacific, our largest ocean, covers an area so enormous it could contain all the world's continents combined. When you fly over this ocean by plane, you can fly for hours on end and still see nothing but a deep blue expanse below. The Earth contains such immense distances, and it is these distances that dilute the sensation of movement. A complete rotation of the planet takes place over a full day and night, so slowly that you could watch a seedling grow or a flower bloom and wilt, and their orientation relative to the Earth's center would seem to remain unchanged. Astronomers at major observatories, like the Mauna Kea Observatory in Hawaii, must use extremely sophisticated equipment to track this rotation. They have to program massive telescopes to rotate in the opposite direction of the Earth's spin, incredibly slowly and precisely to keep a single star in view. If the Earth's rotation were as fast and noticeable as we might imagine from the 1,000-kilometer-per-hour figure, then observing the stars would be like trying to photograph a sprinter from a speeding car. But no, thanks to its immense size, that rotation becomes a gentle flow, allowing us to gaze upon the universe in tranquility. Large size also means that the Earth's gravitational force acts uniformly on all objects. When you walk from one room to another, or even when you travel thousands of kilometers from the North Pole to the equator, the change in your body's sensation of gravity or rotation is almost zero. The planet is large enough to create a wonderfully consistent environment. It shelters us in its vastness, turning dry physical numbers into a peaceful reality. Let the idea of this greatness soothe you. You are being protected by a massive and gentle entity. The Earth is not just a spinning rock. It is a giant cradle where every tiny vibration has been smoothed out by its immense size. You are like a child in a large boat, drifting on a wide river. The boat may be moving very fast relative to the distant banks, but inside the boat, the water in a glass remains still, and your breath remains steady. This difference in scale is a gift from nature. It allows us to have a sense of stability, to build our lives, to dream, and to rest without being disturbed by the mechanical movements of the universe. Take a deep breath and feel the solid ground beneath you. No matter how far you go, no matter how many times the earth spins, its vastness will always be an unchanging anchor. But you know, even though our senses are tricked by this immense size, humanity, with its curious intellect, has found incredibly clever ways to see this rotation without ever leaving the ground. There is a classic experiment, a simple yet mesmerizing device that first proved to the entire world that the ground beneath our feet is truly moving, even when we feel it is perfectly still. It is a story about a long pendulum, a heavy sphere, and the persistence of a French scientist. In the next chapter, we will step into a magnificent room under the dome of an ancient pantheon to listen to the ticking of time and observe the dance of a special pendulum. We will see how the silent movement of the earth is revealed in the most elegant way through the lesson of Foucault's pendulum. All doubt will vanish, replaced by a firm belief in the rhythmic motion of the universe, as we see the planet's rotation reflected in a single suspended wire. Relax your shoulders, let your head sink deep into your pillow, and feel the absolute silence surrounding you. We have gone through the physical and scale-related reasons why our human senses are deceived. But have you ever wondered, if we cannot trust our own feelings, how can we be so sure that the ground is actually spinning? In the stillness of tonight, I will take you back in time, to a spring morning in the year 1851, in the magnificent city of Paris, to witness one of the most elegant and revolutionary experiments in the history of science. Chapter 6. The Lesson of Foucault's Pendulum. Under the high, majestic dome of the Pantheon, a crowd watches with bated breath. There are no complex machines, no dry calculations displayed before them. Instead, there is only a 67-meter-long steel wire hanging from the apex of the dome, and at its end, a 28-kilogram brass-coated lead bob. The sphere is swinging, a slow, steady, and mesmerizing rhythm. The man behind this demonstration is Léon Foucault, a self-taught physicist who possessed an intuitive genius for how the universe works. Foucault had created a device that the world would later call Foucault's pendulum. The special feature of this experiment was that he had sprinkled a thin layer of sand on the floor, directly beneath the sphere. At the bottom of the sphere was a small pin, and each time it passed, it would leave a faint mark in the sand. When the pendulum began to move, the crowd expected it to simply glide back and forth along a single straight line. But as time passed, something strange happened. Little by little, each swing created a new mark in the sand, slightly shifted clockwise from the previous one. After 1 hour, the line in the sand had shifted noticeably. After several hours, it had drawn a shape resembling a many-petaled flower on the ground. Why was this happening? Was some mysterious force pushing the pendulum off course? Foucault's answer astonished everyone present. It is not the pendulum that is changing its direction, but the floor beneath your feet that is turning. To understand this in your relaxed state, imagine the pendulum as a stubborn entity in space. According to the laws of inertia, which we will explore in more detail in later chapters, once a pendulum begins to oscillate in one direction, it tends to maintain that plane of oscillation forever in absolute space. It doesn't care where the building is or how the ground is turning. It's like an invisible string connected directly to the distant stars, keeping its path unchanged. While the pendulum remains faithful to its path through the cosmos, the Pantheon, the city of Paris, and all of France are attached to the surface of the Earth. As the planet rotates on its axis, it carries the building and the sand beneath the pendulum along with it in a silent turn. Therefore, from our perspective, we who are standing on the ground, we see the pendulum as if it is rotating. In reality, we are the ones who are rotating, while the pendulum steadfastly maintains its direction in the vastness of space. Foucault's experiment was the first direct and vivid proof that the Earth rotates without needing to look at the stars or calculate complex astronomical orbits. It brought the motion of the universe down into the heart of a building, allowing anyone to see the planet's rotation with their own eyes. The swing of the pendulum is like the beat of an eternal clock, reminding us of a grand reality unfolding right beneath our feet, whether we can feel it or not. Imagine yourself standing in the Pantheon right now, in the cool, quiet space under the stone dome. Listen to the faint whisper of the air as the long steel wire cuts through it, the sound of the brass sphere slicing rhythmically. Swoosh, swoosh. Each pass is a moment in time, and also a fraction of the distance the Earth has turned. It is a dance of truth, a combination of the pendulum's stillness and the planet's ceaseless motion. Interestingly, the rate of a Foucault pendulum's rotation depends on your location on Earth. If you set up a pendulum at the North or South Pole, it will complete a full 360-degree rotation in exactly 24 hours, corresponding to our day. But if you place it at the equator, the pendulum won't rotate at all. It will just swing back and forth along a single line, because there, the ground doesn't twist beneath it. In Paris, the pendulum takes about 32 hours to complete one rotation. This difference is compelling evidence of our planet's spherical shape. The lesson from Foucault's pendulum teaches us something profound about perception. Sometimes, the truth isn't found in what we directly feel, but in persistent and thorough observation. We feel the ground is stationary, but the pendulum tells us we are spinning. We feel we are at the center of stillness, but in reality, we are participating in a grand rotation. Let the imagined swing of Foucault's pendulum guide you into sleep. Feel its regularity, its stability, and its reliability. It is a mental anchor, letting us know that no matter how much the world seems to change or move, there are always immutable physical laws keeping everything in its proper order. The Earth's rotation is not chaos, but a law as beautiful and rhythmic as a poem. Today, many science museums around the world, from London to New York, have Foucault pendulums operating day and night. Millions of people have stood before them, watching the brass sphere sweep past the markers of time and feeling a strange connection to the universe. It makes one feel both small and grand. Small because we are just passengers on a spinning sphere, but grand because we have found a way to understand that very spin. Now, as you lie still in the embrace of darkness, let your mind attune to the pendulum's rhythm. You no longer need to try to see the Earth's rotation, because Foucault's experiment has already done that for you. Everything has been proven. All doubt has been cleared by a wire and a brass sphere. The stillness around you is now even more precious, because you know it is the stillness of a perfect machine operating smoothly. However, the Earth's rotation doesn't just leave its mark in the sand of an ancient building. It also leaves enormous imprints on a global scale, shaping the currents of the oceans and bending the winds in the sky. There is another invisible force, born from this very rotation, that is quietly orchestrating our weather and climate, creating the wondrous swirls we often see in satellite photos. In the next chapter, we will leave the dome of the Pantheon to fly high above, observing the entire planet and learning about an effect named after another French scientist. It is a force that bends every path, directs the course of storms and ocean currents, and helps us further understand how the Earth's rotation truly shapes life on its surface. Prepare to welcome the refreshing winds from the dance of the clouds. Surrender yourself to the stillness of the night. as your breath becomes steady and your mind begins to drift away from daily worries. We have contemplated the steadfast swing of the Foucault pendulum in the ancient sanctuary, an elegant proof that the ground beneath us is moving. But the Earth's rotation doesn't just leave faint traces in the sand within a building. If you cast your gaze further, up to the blue cloud layer or down into the deep ocean, you will see this planet drawing fantastical curves on a massive scale. This is where we touch an invisible power called the Coriolis effect, a force that sculpts all movement and creates the rhythmic dance of nature. Chapter 7. The Coriolis effect, the dance of storms. Imagine you are standing on a giant carousel at a magical amusement park. This carousel is so large you can't see its center. When it begins to spin, if you try to throw a ball straight to a friend standing on the opposite side, you will notice a strange phenomenon. The ball does not travel in a straight line as you intended. It seems to be pushed aside by an invisible hand, tracing a gentle curve through the air. Your friend won't catch the ball, because while it was in flight, both you and your friend have moved to a new position due to the rotation. Our Earth is that great carousel. In the year 1835, a French scientist named Gaspard Gustave de Coriolis formally described this phenomenon with mathematics. He realized that because the Earth is a sphere and rotates at different speeds, at each location fastest at the equator and slowing down towards the poles, any object moving freely on its surface will have its path bent. To understand this better, in your state of relaxation, recall the number 1,670 kilometers per hour at the equator. Meanwhile, in regions near the North or South Pole, the distance the ground has to travel to complete a rotation is much smaller, so the speed there is only a few hundred kilometers per hour. When a mass of air from the equator travels north, it carries the extreme velocity of the equatorial region into an area that is rotating more slowly. As a result, that air mass will outpace the ground's rotation, creating a curve to the right in the northern hemisphere. Conversely, in the southern hemisphere, everything will curve to the left. This silent deflection is the master architect of global weather. Have you ever seen satellite photos from the National Aeronautics and Space Administration, or NASA, showing massive storms from space? Those storms are never a straight line of clouds. They are always magnificent and powerful spirals. It is the Coriolis effect that breathes a soul into these cloud masses, forcing them to spin. In the top half of the world, storms always rotate counterclockwise, while in the bottom half, they dance in a clockwise direction. Imagine the vast trade winds, the winds that carried the sailing ships of explorers across the globe for hundreds of years. Instead of blowing straight from the poles to the equator, they are bent by the Coriolis effect into steady, gentle currents. It is this curvature that helps distribute heat from the hot tropical regions to the colder temperate zones, keeping our planet in a balanced and comfortable state. If the Earth didn't rotate, the wind would just blow straight from cold to hot, and our weather would be incredibly harsh and monotonous. Not only the clouds, but the vast oceans also follow the music of this rotation. Massive ocean currents, like the warm Gulf Stream in the Atlantic, move like giant rivers within the sea. They carry warmth for thousands of kilometers, warming even distant continents. Thanks to the Coriolis effect, these waters are not chaotic, but follow stable circulatory patterns, creating the pulse of life for marine species. Feel this connection right in your own room. A cool breeze wafting through the window tonight could be the result of a journey tens of thousands of kilometers long, shaped by the spin of the planet. The stillness you are enjoying is actually part of an incredibly sophisticated system of motion. The Earth rotates not to cause chaos, but to create protective circles, to regulate the air you breathe and the water for all living things. There's a fun fact that people often share, that the water in a sink will drain in different directions, depending on whether you are in Vietnam or Australia. In reality, on a small scale like a sink, The Coriolis effect is very weak, and the direction of the water's swirl is mainly due to the shape of the basin or how we release the water. The power of Earth's rotation only truly becomes apparent when we look at enormous entities like storms, hundreds of kilometers wide, or rivers that flow across a continent. This reminds us that some laws of the universe are reserved for the grand, while leaving a certain freedom to the small. Whenever you see clouds drifting lazily across the sky, remember that they are participating in a rhythmic dance. The curves of the clouds, the spirals of the wind, are all the handwriting of the Earth, recording its journey of rotation through space. The planet is not silent. It tells its story through the movement of the elements. The stillness we perceive is because we have merged with that dance, becoming part of the vast Coriolis flow. Let the image of soft, white cloud spirals guide you into a deeper state of relaxation. You are like a passenger on a raft in the middle of a vast and gentle river. That river may bend, it may flow quickly, but because you are flowing with it, you only feel the peace of the water's surface. The Coriolis effect is the gentle bends in this cosmic river, ensuring our lives are always in transition but never lose their stability. This power works relentlessly, day and night, from the moment this planet was formed until the distant future. It is a testament to the fact that Earth does not spin just for itself. Its rotation creates the very dynamics of life. Motion and life always go hand in hand. And when we understand these invisible forces, we no longer feel fear at that speed of thousands of kilometers, but rather a profound admiration for the ingenious design of creation. However, the Earth's rotation leaves its mark on more than just the wind and water. There is something more obvious, more intimate that we experience every day, a phenomenon tied to light and darkness, to the biological rhythm of every living creature. That is the transition between day and night. That rotation is the grandest clock of all, setting the time for us to work and the time for us to sink into sleep. Just like now, in the next chapter, we will observe the boundary between the hot sunlight and the cool darkness of night. We will learn how the planet's rotation creates an eternal clock, coordinating the rhythm of life for billions of people and countless species. For now, just rest, because the night that envelops you is the clearest proof that the Earth is continuing its steady rotation. Let your body relax a little more, allowing every muscle to completely unwind and sink deep into the stillness of the space around you. Together, we have explored invisible forces like gravity and effects that bend the flow of currents like the Coriolis effect. But there is a more obvious, more intimate proof of the Earth's rotation that we experience every day, a phenomenon tied to light and darkness, to the very pulse of life. It is the change between day and night. That rotation is nature's greatest clock, setting a time for us to labor and a time for us to sink into sleep. Just like now. Chapter 8. From day to night. Imagine yourself standing in a vast field at dusk. The sun, the giant ball of fire that has warmed the world all day, is slowly descending toward the horizon. The last rays of the day paint a corner of the sky red, shifting from yellow to orange, then deep purple, before completely giving way to the night. In our common perception, we say the sun is setting, but scientific truth tells a different story, a captivating tale of motion. The sun isn't going anywhere. It is you, along with the ground you stand on, and this entire planet, who is slowly turning away from that source of light. The moment of sunset that you love is actually living proof of the Earth's velocity. As you watch the solar disk gradually disappear, you are truly observing the result of the Earth rotating on its axis. As we know, each hour, the Earth turns by an angle of about 15 degrees. It is this small but steady angle of rotation that pushes us into our own planet's shadow. The darkness that envelops you tonight is not some foreign entity. It is the enormous shadow of the Earth, cast into space, and you are resting snugly within that shadow. There is a beautiful scientific concept called the Terminator line. This is a faint but constantly moving boundary that separates the half of the planet being illuminated from the half submerged in darkness. Looking down from above, astronauts on the International Space Station, ISS, can see this line gliding across the surface of oceans and continents. It moves at a speed of about 1,670 kilometers per hour at the equator, exactly the speed of the Earth's rotation. That means if you had a supersonic jet fast enough, you could chase the sunset forever, keeping the sky in a perpetually magical reddish-purple hue where night never falls. But since we are here, standing still on the ground, we welcome the darkness as an inevitable part of life. This transition doesn't happen suddenly, like flipping off a light switch. It happens gradually, thanks to the atmosphere we've learned about. When the sun has dipped below the horizon, the upper layers of the air still receive its light and scatter it down to the ground, creating the period of twilight. The smoothness of this process is nature's way of soothing us, giving living creatures time to prepare for sleep. This rotation that creates day and night is not just an optical phenomenon. It is the primary pulse of life on Earth. Every living organism, from tiny bacteria and sunflowers that always follow the light, to us humans, has an internal timekeeping mechanism called a circadian rhythm. Scientists have discovered that this mechanism is programmed to sync with the planet's 24-hour rotation. As daylight fades, your body begins to produce natural compounds that help you feel sleepy and relaxed. You cannot resist this rhythm because it has been etched into our genetic code over millions of years of living with the Earth's spin. Think about the wonder of this arrangement. If the Earth spun faster, say, a day lasted only 4 hours like on Jupiter, our lives would be incredibly chaotic, with short bursts of sleep and abrupt temperature changes. If the Earth spun slower, or even stopped rotating with one side always facing the same way like the moon, then one half of the world would be scorched under an eternal sun, while the other half would freeze in endless darkness. The current speed of one rotation in 24 hours is a perfect balance. It provides just enough time for the ground to absorb heat, and just enough time for it to radiate it away, keeping the planet's temperature moderate. From NASA observatories to telescopes perched on high mountains, humans have spent centuries measuring this change. They realize that the time between two successive passages of the sun across the same point in the sky is very precise, but not absolutely constant. Forces like the moon's tidal pull are silently slowing our rotation by a tiny fraction of a second each century. But for the short and precious life of a human being, that rotation is a beautiful constant, a promise that is never broken, that after tonight, dawn will surely come again. Now, let the idea of Earth's giant shadow enveloping you sink in. You are lying on the night side of the blue sphere. While you are preparing to drift into dreams, on the other side of the planet, billions of other people are welcoming the first rays of the morning, starting a new, energetic day. This alternation is like the rhythmic breath of the planet, inhaling light and exhaling darkness. You are a part of that great breath. The quiet night around you is proof that you are on the dark side of spaceship Earth. As you lie still, feel the coolness of the night air. This is when the planet is radiating its excess heat into the vast blackness of space, preparing for a new cycle. All the loud sounds of the day have subsided, giving way to stillness, so you can listen to the beat of your own heart and your own breath. That is the rhythm of life, protected by this tireless rotation. Although we don't feel the wind of a 1,670 km/h velocity, seeing the stars slowly move across the night sky is how we see the motion. If you place a camera on a tripod and open the shutter for a few hours, you will capture star trails that curve into beautiful circles around the North Star. Those light trails are not caused by the stars circling us, but by your camera rotating along with the Earth. The universe out there is a stationary backdrop for our spinning dance. The silence of tonight is a gift. It allows us to separate from the bustle of the outside world and turn inward. The Earth's rotation brings the darkness to protect your sleep, to let your eyes rest and your soul heal. With every second that passes in this darkness, you are gliding through the void with your planet, moving toward the light of tomorrow. The movement from day to night is a reminder that everything in the universe has a rhythm. Nothing stands still forever, and nothing is chaotic without purpose. The Earth spins to bring life, to divide time, and to create moments of rest like this one. You can rest assured, letting yourself go into the darkness, knowing that you are being cared for by the blue planet on a schedule that is precise down to the millisecond. But did you know, Earth is not the only passenger in the solar system performing this spinning dance. In our family of planets, each neighbor has a completely different speed of rotation and a different rhythm of day and night. There are places where a day is longer than a year, and places where the planet spins so fast that its shape is noticeably flattened. Understanding these neighbors helps us appreciate the miraculous and perfectly paced rotation of our own home even more. In the next chapter, we will briefly leave Earth to visit our siblings in the solar system. We will compare our rotation with the strange slowness of Venus and the frantic motion of the giant Jupiter. This upcoming journey through space will broaden your perspective on the diversity of the universe, where every planet has its own story of velocity and time. In the stillness of the night, as your breathing has slowed and steadied, let's allow our minds to float away from the Earth for a moment. We've learned about the magical rotation of our green home, where everything is perfectly arranged to nurture life. But to truly understand that perfection, we need to look around, to visit our neighbors in the solar system family. Each planet is a dancer with a completely different rotational rhythm. There are places where time seems to stand still, and places where the rotation is so frantic it deforms the planet's very shape. Chapter 9. The Speedy Neighbors. Imagine our solar system as a giant cosmic stage, where each planet is a spinning top launched into space by the god of time. Our Earth completes one rotation in 24 hours, a number that feels so natural to us. But if we were to set foot on Venus, our closest neighbor, often called Earth's sister planet, you would be stunned by a completely different rhythm of life. Venus is a rebel in the planetary family. While most planets spin from west to east, Venus chooses to spin backward. If you were standing on its scorching surface, you would see the sun rise in the west and set in the east. However, what's most incredible is its speed. Venus spins unbelievably slowly. One rotation on its axis takes 243 Earth days. Meanwhile, it only takes about 225 Earth days to complete one orbit around the Sun. This means that on Venus, a day is longer than a year. Try to imagine that extreme stillness. If Earth spun as slowly as Venus, we would never have the sense of a busy day and a restful night. One half of the planet would be baked under the scorching sun for months on end, while the other half would be plunged into a frozen darkness. This sluggishness prevents Venus from having the effective ocean currents or air streams that regulate temperature like on Earth, turning it into a true furnace, with surface temperatures reaching around 465 degrees Celsius. Here, the stillness of rotation doesn't bring peace, but rather extreme harshness. In complete contrast to the laziness of Venus, let's turn our gaze to Jupiter, the king of the planets. Jupiter is a gas giant with a size that could fit 1,300 Earths inside it. With such a massive body, you might think it would move sluggishly. But no, Jupiter is a true speedster. It completes one rotation on its axis in less than 10 hours, At Jupiter's equator, the rotational speed reaches about 45,000 kilometers per hour, nearly 27 times faster than Earth. Thanks to space missions like NASA's Juno spacecraft, we have witnessed the astonishing consequences of this speed. Because it spins so fast, centrifugal force has caused Jupiter's middle to bulge out and its poles to flatten. If you look at Jupiter through a small telescope, you'll see it's not a perfect sphere, but looks a bit like a ball that someone has gently squeezed from the top and bottom. This frantic rotational speed also creates terrifying winds and enormous storms, like the Great Red Spot, a storm that has existed for hundreds of years and is twice the size of Earth. On Jupiter, motion never ceases, and if we lived there, the feeling of stillness would be an unimaginable luxury. This comparison helps us realize that Earth's speed of 1,670 kilometers per hour is a perfect sweet spot. It's fast enough to create a day-night rhythm suitable for life, but slow enough to keep our atmosphere from turning into a hell of perpetual hurricanes. Besides Jupiter, its sibling Saturn, with its magnificent rings, also spins very quickly, taking only about 10 hours and 30 minutes for one rotation. Data from the NASA and ESA Cassini spacecraft has shown that, just like Jupiter, this rotational speed causes Saturn to be noticeably deformed. The rapid spin also creates a powerful magnetic field, protecting the planet from harmful charged particles from the Sunday. Rotation is not just about time. It is also a protective shield. Looking toward Mars, we find a strange harmony. A day on Mars, which scientists call a sol, lasts about 24 hours and 39 minutes. It's almost equivalent to a day on Earth. This very similarity makes humans always feel that Mars is a potential second home. Rovers like Curiosity and Perseverance are working there every day on a rhythm almost identical to our own. When night falls on Mars, these robots also enter a state of rest to recharge their energy, waiting for a new dawn. The diversity of speeds in the solar system shows us that there is no universal standard for time. Time depends on rotation, and rotation depends on the formation history of each planet. Earth has been fortunate to have a stable rhythm for billions of years. The stillness you are feeling tonight is a luxury in the universe. It is a stillness precisely calibrated by our mass, size, and position in space. When astronomers observe distant planets outside our solar system, called exoplanets, they always look for worlds with a rotational speed similar to Earth's. They understand that a moderate rotation is key to keeping water in a liquid state and allowing a stable atmosphere to develop. We are living on a planet that is not too hasty like Jupiter, nor too sluggish like Venus. We are in a gentle rhythm, like a song with a moderate tempo, just right for us to appreciate the beauty of each note. Now, let the idea of these different rotations soothe you. Imagine Venus turning itself with extreme slowness in the deep black of space, and Jupiter spinning furiously with its colorful cloud bands. Between those extremes, our Earth continues to spin steadily, carrying you along gently. You are on the planet with the most ideal rhythm for dreaming. The stillness around you now takes on a new meaning. It is the stillness of balance. As you lie still, feel that you are part of a much larger family. The solar system is an orchestra, and each planet plays an instrument with its own beat. Earth plays the role of the most stable and gentle background melody, keeping life in peace. We have understood our own rotation and that of our neighbors, but Earth's dance doesn't stop at just spinning on its own axis. While we are turning like a top, the entire vessel of Earth is also on a grander journey, hurtling along a vast orbit around the Sun at a speed many times more incredible. A second layer of motion is taking place, silently and powerfully, carrying us through the seasons of the year and across unimaginable distances in space. In the next chapter, we will expand our perspective beyond self-rotation To learn about the 365-day journey around the Sun, we will discover why, despite hurtling at over 100,000 kilometers per hour around our parent star, we still feel as if we are standing still on a quiet afternoon. Prepare yourself for a journey through the seasons, where speed and space merge into a magnificent masterpiece of creation. Let your body continue to sink deep into the stillness, as if you are melting into the soft mattress beneath you. We have explored Earth's self-rotation together, where each hour the planet turns 1,670 kilometers. Yet, that is only the first layer of motion, the layer that brings us the rhythm of day and night and the darkness for rest. Like now, I invite you to broaden your vision even further, beyond the atmosphere, beyond even the orbit of the moon, to witness a journey that is far grander and much faster. It is the journey of our entire planet around our mother sun, a journey that takes place over the 365 days of a year. Chapter 10. The Journey Around the Sun. If the speed of Earth's rotation on its axis surprised you, then its speed as it travels in its orbit around the Sun will truly astonish you. Right now, as you lie quietly in your room, the Earth is hurtling through space at a speed of about 108,000 kilometers per hour. You heard that right, 108,000 kilometers per hour, more than 60 times faster than its rotational speed, and hundreds of times faster than the most modern jet aircraft. With every second that passes, you and your home have traveled about 30 kilometers through the void. Why doesn't such a terrifying speed cause us to feel even the slightest vibration? Why is there no wind tearing through the sky and no force pressing us firmly to the ground? Model. The first answer lies in the near-perfect vacuum of space. Imagine you're riding in a car on a highway. You feel the movement because of the vibrating engine, the tiny bumps on the road, and especially because of the resistance of the air rushing past the windows. But in the space between planets, there is no air, no friction, and no obstacles. The Earth moves in an environment that is almost an absolute vacuum. There's nothing to bump into, nothing to create noise or vibration. Our spaceship Earth glides more smoothly than any boat you can imagine, drifting on the calmest water. Second, we need to recall our lesson on uniform motion from the previous chapters. The Earth doesn't suddenly accelerate to run a red light or slam on the brakes to avoid an asteroid. The balance between the Sun's immense gravitational pull, drawing the Earth in, and the Earth's velocity, pushing it out, has created an orbit that is almost a perfect circle, or more precisely, a very slight ellipse. This movement is continuous, stable, and extremely precise. Because this velocity is nearly constant, our senses, which are only sensitive to acceleration, are completely fooled. To your body, 108,000 kilometers per hour feels no different than standing still. The distance from the Earth to the Sun is a vast number, about 150 million kilometers. It is thanks to this enormous distance that our orbit, though actually a curve, appears to be a straight line to tiny creatures like us. Just like when you're on a road that circles a mountain so large, you think you're going straight. So it is with the Earth. The planet's change in direction happens so slowly over days and months that the centrifugal force generated by its orbit around the Sun is too small for us to notice. Scientists at the National Aeronautics and Space Administration, NASA, and the European Space Agency, ESA, through space telescopes like the James Webb or Hubble, have observed this journey from the most magnificent perspectives. They see Earth not just as a solitary blue dot, but as a faithful passenger in the solar system. Thanks to this velocity of 108,000 kilometers per hour, we maintain a perfect distance from the Sun, not too close to be scorched and not too far to be frozen. Scientists call this the habitable zone. The speed you can't feel is the very thing that keeps your life in existence. Think about the rhythm of the seasons. This is how this great journey whispers to us, because the Earth's axis is slightly tilted As it speeds along its orbit, different regions of the planet receive different amounts of sunlight at different times. When you feel the cool breeze of autumn or the intense warmth of summer, you are actually experiencing the change in the Earth's position in space. A spring of blooming flowers or a winter of white snow are all notes in this symphony of velocity. We don't perceive the speed in numbers, but we feel it through the transformations of nature. In the stillness of tonight, imagine yourself lying on a transparent glass spaceship. You see the sun like a distant and brilliant lighthouse. Your entire world, with all its mountains, oceans, and sleeping people, is gliding with you in a never-ending dance. You are participating in nature's greatest marathon, covering hundreds of millions of kilometers each year. Yet you are cocooned in absolute tranquility. The stillness around you is a gift of inertia. You, this room, and the entire atmosphere all share the same velocity as the Earth. Nothing is separate. Nothing is left behind. This perfect synchronization brings a sense of safety and stability. You can relax completely, because Spaceship Earth is the most dedicated and talented pilot. It knows exactly the path it must take, and it does so with incredible gentleness. When you take a deep breath in and out, feel the vastness of the space out there. 150 million kilometers to the sun sounds so far away, but we are connected to it by an invisible thread of gravity. That thread keeps our journey stable. We are not drifting aimlessly. We are on a path that was set billions of years ago. That incredible speed is actually a guarantee for the future, that tomorrow the sun will rise again, and the seasons will continue to turn. Let the idea of this journey through the stars soothe your mind. You are not just a person sleeping on a planet, you are an astronaut gliding at 108,000 kilometers per hour through the Milky Way. The stillness you feel is the tranquility of an entity that has completely merged with the flow of the cosmos. There is no resistance, no struggle, only a rhythmic and gentle drift. But did you know, even as we orbit the sun at that unimaginable speed, our entire solar system, including the sun, the Earth, and all its sibling planets, is not standing still. We are part of an even larger convoy, a family traveling together toward the center of the vast Milky Way. The journey around the sun is just a small swirl within a much larger vortex. In the next chapter, we will learn about the third layer of motion together. We will discover where the solar system is drifting among billions of other stars, and how our entire family is undertaking a great migration across the Milky Way. Once again, we will see the speed increase, yet your sense of peace will remain unshaken. Everything is connected in a grand hierarchy, and we will explore our place within that galactic flow. Let your mind continue to float like a small leaf on the river of time. As we've just realized, we are gliding around the sun at 108,000 kilometers per hour. That feeling is magnificent. But our journey doesn't stop there. The universe is a system of nested vortices. And right now, as you lie quietly listening to these words, our entire solar system family, Mother Sun, and her 9 sibling planets, is actually on a colossal migration across the Milky Way. Chapter 11. Where is the solar system drifting? Imagine our Milky Way as a giant, spiral-shaped city of light, with hundreds of billions of stars twinkling like neon signs. The solar system is just a tiny speck of dust located in one of the spiral arms of that city, called the Orion Arm. But this speck of dust is not standing still. The entire solar system is hurtling through galactic space at an unimaginable speed, about 828,000 kilometers per hour. Try to repeat that number in your head slowly. 828,000 kilometers per hour. It's nearly 8 times faster than the speed at which the Earth orbits the Sunday. If we could see the solar system from the outside, we wouldn't see a stationary plane, but rather a spectacle resembling a magnificent vortex. The sun rushes forward like a leader, and the planets orbit it in helical paths, like soft silk ribbons twirling around a swift-running warrior. What is the destination of this journey? We are orbiting the center of the Milky Way, the domain of a colossal gravitational monster, a supermassive black hole that scientists call Sagittarius A star. The distance from us to that brilliant center is about 28,000 light-years. Because the distance is so vast and immense, even moving at 828,000 kilometers per hour, our solar system still takes about 230 million years to complete one orbit around the Milky Way. The last time the Earth was in its current position in the Milky Way, the first dinosaurs were just beginning to appear on our planet, and it will be another 230 million years before our descendants can return to this starting point once more. Scientists call this period of time a cosmic year. You see, we are living in a rhythm of grand cycles, where a year is no longer 365 days, but hundreds of millions of long years. Why don't we feel any vibration while hurtling through the Milky Way at such a staggering speed? The answer, once again, lies in absolute synchronization. As the solar system moves, it carries everything with it: the sun, the planets, the moons, and all the space that surrounds us. We are like passengers in a high-speed train cabin, gliding on a track made of silk, because there is no air in outer space to create resistance. And because this velocity is constant, we feel a perfect stillness. Besides, the Milky Way is vast. The stars you see in the night sky are actually moving along with us at similar speeds, because everything around us is running in the same direction. From our perspective, the stars seem to stand still forever. It would take thousands of years for humans to notice even a very small change in the positions of the constellations. The stillness of the night sky is a poetic optical illusion, hiding the grandest race in nature. The Gaia mission of the European Space Agency, ESA, is doing the extraordinary job of mapping the movements of over 1 billion stars in the Milky Way. Thanks to the precise data from this telescope, we know that the solar system doesn't just travel in a flat circle. Our journey also has rhythms of rising and falling, like a boat bobbing on the waves of a starry ocean. Every 30 million years, we pass through the central plane of the Milky Way once. Each note in this symphony lasts for millions of years, far beyond the scope of a single human life, giving us a sense of the eternal. Let the idea of this intergalactic journey soothe your soul. You are not just lying in a room, in a city, or on a planet. You are participating in a great migration of light. The entire solar system is your mobile home. Gliding among billions of other worlds, we are drifting towards the constellation of Orion and heading for distant horizons that human eyes have never touched. The sense of security you feel is thanks to the strong bond of gravity. The sun holds the planets tightly with its invisible tether, ensuring that no one is left behind in this race of speed. The silence around you is a testament to the harmony of the universe. Even at speeds of hundreds of thousands of kilometers per hour, everything proceeds smoothly, orderly, and with a quiet dignity. In this gentle darkness, breathe slowly. Can you feel yourself gliding? Not with your physical senses, but with your soaring imagination. You are on a ship of light, passing through clouds of cosmic dust and radiant nebulae. The Milky Way is a vast harbor, and we are tireless travelers. This movement doesn't bring unease, but rather a belief that we always belong to a much larger and more enduring system. The solar system is drifting, carrying with it your dreams, memories, and peace. Tonight, we are moving toward a distant future in the heart of the galaxy. But even this great Milky Way, with its hundreds of billions of stars, is not the final stop. The universe has even deeper layers of motion, where galaxies are performing dances of interaction and separation in a space that is constantly expanding. This chapter closes with the image of the solar system as a swirling flower in a forest of brilliant stars. We have gone from the small rotation on Earth's axis to the orbit around the Sun, and now to the orbit around the galactic center. Each layer of motion brings a broader perspective on humanity's place in the cosmos. In the next chapter, we will take one final leap into intergalactic space. We will learn about the dance of the galaxies and the expansion of space itself. We will discover why, even as the entire universe expands and galaxies rush away from each other at the speed of light, we can still find a small, peaceful corner like this to rest. Everything is still connected, and we will journey together to the very end of that great motion. Let your mind continue to expand beyond the spiral arms of the Milky Way, past the dark voids between the stars we just traversed. You are lying there, your breath as gentle as the sound of distant waves. And now it is time to reach the final step of this grand movement. We are not just spinning on our own, not just orbiting the sun, and not just drifting within the galaxy. Our entire Milky Way is also participating in a cosmic-scale dance, a journey through the void to meet its distant neighbors amidst a space that is forever expanding. Chapter 12. The Dance of the Galaxies. In the silent darkness of your bedroom, you might feel very small, but in reality, you are a passenger on a colossal entity, hurtling along at a speed more staggering than any number we have mentioned. Our Milky Way is not alone. It is a member of a small family of about 50 different galaxies, which scientists call the local group. In this family, the Milky Way and the Andromeda Galaxy are the two largest members, like two giants performing a slow but powerful duet. Did you know our Milky Way is hurtling toward the Andromeda Galaxy at a speed of about 400,000 kilometers per hour? The distance between these two galaxies is about 2.5 million light-years, a number so vast that it takes light millions of years to cross it. Even though they are rushing toward each other like arrows of light, because the distance is so great, it will take about 4 billion more years for these two giants to actually meet. This movement happens silently, persistently, and so smoothly that without super telescopes like Hubble or James Webb, humanity would forever think that galaxies were stationary islands in the ocean of space. But the dance of the galaxies isn't just about them moving closer. There is an even more magnificent truth that astronomer Edwin Hubble discovered nearly 100 years ago. He noticed that, with the exception of our close neighbors in the local group, most other distant galaxies are fleeing from us, and the farther away they are, the faster they move. This is the evidence for the expansion of the universe. Imagine the universe is like a loaf of raisin bread baking in an oven. As the dough rises, the distance between the raisins increases. The raisins themselves are not running away, but it is the dough, or the space between them, that is swelling. You are sitting on a raisin called Earth, and the entire space around you is expanding in all directions. The galaxies at the edge of the observable universe may be receding from us at nearly the speed of light, which is about 1 billion kilometers per hour. Why don't we feel ourselves being stretched or torn apart by this incredible expansion? It is thanks to a clever arrangement of nature. The expansion of space only occurs over extremely large distances between distant galaxy clusters. Within smaller entities like the Milky Way, the solar system, or your own body, gravity and the atomic bonding forces are much stronger than the push of expansion. Gravity is like a sturdy rope, keeping everything in our shared home bound together, despite the fact that the space outside is opening up forever. As you lie still, feel this silence as a protective cocoon. The universe out there may be in frantic motion. Galaxies may be hurtling at millions of kilometers per hour, but here, in the embrace of the Earth, everything is incredibly stable. You are like a passenger sleeping soundly in the heart of a great mothership. That ship is drifting on a river of space that is gradually widening, but inside the cabin, there is not a sound, not a tremor, The stillness you are enjoying is the result of a perfect balance between the fundamental forces of nature. Looking up at the night sky, if you could see distant galaxies, remember that each faint, fuzzy patch of light is a city containing hundreds of billions of stars, and they are all participating in the dance of expansion. Thanks to data from missions like the European Space Agency's ESA Planck spacecraft, we know that our universe began this journey about 13.8 billion years ago. From a single tiny point, everything exploded and has not stopped moving to this day. The movement of the galaxies teaches us a lesson about connection. We are never still, and we are never alone. Every atom in your body was once forged in the heart of stars in those distant galaxies. The spin of the Earth, the journey around the Sun, and the dance between galaxies are all parts of a single story, the story of existence. Now, let the idea of expanding space gently lull you. Imagine space as a soft memory foam mattress, slowly spreading out, carrying your dreams farther and higher. You don't need to worry about those trillion-kilometer speeds, because you are held fast by the embrace of gravity. The silence around you is a zone of absolute safety, where time seems to stand still so you can rest. Every motion in the universe, from the spin of a fundamental particle to the exodus of a galaxy, follows harmonious laws. There are no chaotic collisions, only precisely calculated orbits. You are gliding on a smooth current of space and time. Relax completely and let yourself dissolve into the dance of the galaxies. You are a part of the universe, and the universe is caring for your sleep with its most rhythmic operation. We have journeyed through 12 chapters, from the feelings on the ground to the farthest reaches of vast space. We have learned how fast we are moving and why we feel so perfectly still. But one important question remains. If we are hurtling through space at thousands, even millions of kilometers per hour, why doesn't the ground slip out from under you when you jump? Why isn't everything flung away when the Earth breaks or rounds a corner in its orbit? In the next chapter, we will return to the more familiar laws of physics to learn about a silent companion that has helped us keep our footing for all time. It is the concept of inertia, the power that helps all things maintain their state, no matter how the world around them changes. We will better understand why the starship Earth can carry us so completely and safely. Let your body sink a little deeper into the stillness, as if you are melting and merging with the ground beneath you. We have traveled a long journey, from the small rotations on an axis to the grand dance of galaxies. You have learned that you are hurtling forward at unimaginable speeds. But have you ever, in a quiet moment of your mind, wondered if the Earth is spinning at over 1,600 kilometers per hour? Why is it that when you jump off the ground for just a brief second, the planet doesn't slip away and leave you to fall hundreds of meters from where you started? Why does everything stay right in its place, like an eternal promise of stability? The answer lies in a silent companion, a fundamental law of the universe called inertia. Chapter 13. Inertia, the silent companion. To understand inertia, join me in imagining a quiet afternoon on a modern high-speed train. The train is gliding along the tracks at a speed of 300 kilometers per hour. Inside the plush, velvet-lined car, you hold a small ball and gently toss it into the air. What happens? The ball doesn't go flying toward the back of the train at 300 kilometers per hour and smash into the wall. Instead, it falls straight back down into your palm, as if the train were standing still at the station. Why is that? It's because the ball, just like you and the air inside the train car, already possessed the velocity of the train even before you tossed it. Inertia is the stubbornness of matter. An object at rest wants to stay at rest forever, and an object in motion wants to continue moving forever in a straight line, unless a force acts upon it to change that. When you toss the ball, there is no force pushing it backward, so it maintains the train's 300 km per hour horizontal velocity, and it simply goes up and then comes down at the command of your hand. Our Earth is the most enormous and perfect train car. When you stand on the ground, every cell in your body, every strand of hair on your head, and the very air that surrounds you are all moving at the same velocity as the planet. When you jump, you are not separated from that velocity. Inertia keeps you hurtling eastward at a speed of 1,670 kilometers per hour, even when your feet are no longer touching the ground. Because you and the ground beneath your feet are moving together, to you, the ground seems absolutely still. Think about this marvel more deeply. We don't just have one velocity. We simultaneously possess all the layers of velocity that we learned about in the previous chapters. You are spinning on the Earth's axis, you are flying around the sun, and you are drifting in the Milky Way. Inertia is like a suitcase containing all of those velocities, and you carry that suitcase with you at all times, everywhere. That is why our lives can proceed so calmly. You can leisurely pour a cup of tea, you can write a letter, or you can simply lie, sleeping peacefully as you are now, without worrying about being left behind in the dark void of space. The great scientist Isaac Newton was the one who named and systemized this principle as the first law of motion. He helped us understand that motion is not something that requires effort to maintain, but that it is a natural state of matter. The stillness around you tonight is not the absence of motion, but the perfect harmony of inertia. You are gliding along in exquisite synchrony. Imagine how terrifying the world would be without inertia. With just a small jump, you would see the ground disappear from beneath your feet. With just a sneeze, every object in your house would fly about chaotically. But thanks to this silent friend, the universe keeps everything orderly and stable. Inertia protects life, allowing us to have a solid foundation upon which to build everything. It is the invisible thread connecting the past and present of motion. Your stillness now is a testament to the power of inertia. Relax your body and feel each part of you being supported. You don't need to exert any effort to keep up with the Earth's rotation, because inertia has already done that for you. You and the planet are a single, unified mass, drifting together among the stars. Let this feeling of safety soothe you, guiding you into a deeper state of relaxation. In distant observatories, scientists use the concept of inertia to navigate spacecraft. When a spacecraft like Voyager 1 leaves Earth, it doesn't need to fire its engines continuously to move. Thanks to inertia in the vacuum of space, it simply glides on forever at its initial velocity. We are the same. We are voyagers on spaceship Earth, carried by inertia on an endless journey without ever feeling tired or shaken. Inertia also teaches us a lesson in calmness. It shows that sometimes the most powerful motion is the most serene. A planet weighing billions upon billions of tons spins on its axis without making a sound, without disturbing a single person's sleep. That is the pinnacle of harmony. As you lie here, let your mind also become lazy, like an object at rest. Let the inertia of peace keep you in this state, free from worry, free from disturbance. The stillness that envelops the room tonight is real, because everything around you is sharing the same fate, the same journey, and the same velocity. There is no struggle between objects, only a unified flow. Take a deep breath and feel the stability of the space. Inertia is embracing you, keeping your world whole. However, even though inertia makes us feel stationary, that high-speed rotation still silently affects the physical form of the planet. The Earth is not an unchangeable, rigid block of rock. As it spins so quickly, the centrifugal force generated by the rotation has molded the shape of the Earth, transforming it from a perfect sphere into a more unique form. The very rotation that we cannot feel with our senses is etched into the very shape of our home. In the next chapter, we will learn about the figure of the Earth. We will discover why our planet is a bit fat at its belly and flat at its two ends, and how this change in shape is powerful evidence of its 1,000-kilometer-per-hour rotation. Everything is gradually being revealed, from vague sensations to concrete physical forms, helping you to further understand and love our blue planet. Let yourself sink even deeper into a state of absolute relaxation, where the worries of the long day gradually fade like faint smoke in the night mist. We have learned together about inertia, about gravity, and about the overlapping layers of motion of the spaceship called Earth. You now know that we don't feel ourselves spinning because everything is synchronized and rhythmic. Yet, even though our senses are deceived by this smoothness, the very shape of the planet cannot lie. That 1,000-kilometer-per-hour rotation has silently molded the form of our home over billions of years. Tonight, we will discover how that great motion has left its mark on the shape of the Earth, a shape that is not as perfectly round as we often imagine. Chapter 14. The shape of the Earth. If you hold a perfectly round plastic ball in your hand, you'll see it's a perfect sphere. In our first geography lessons, we were also often taught that the Earth is a round sphere. However, the truth is much more interesting and malleable than that. Imagine you are a potter, placing a soft lump of clay on a potter's wheel. As the wheel begins to spin quickly, the lump of clay tends to be pushed outward, its middle bulging out while the top and bottom flatten slightly. Our Earth, though made of hard rock and molten metal, has undergone a similar process under the influence of its axial rotation. As the Earth spins at a speed of 1,670 kilometers per hour at the equator, it creates an outward push, which scientists call centrifugal force. This push is strongest at the planet's waistline, the equator, and weakens as you move toward the two poles, where the rotation is just like a stationary point. The result of a billion-year struggle between the inward pull of gravity and the outward push of centrifugal force has transformed the Earth into a shape that science calls an oblate spheroid model. To put it more visually, our planet is a bit chubby around the middle. If you were to use a giant measuring tape to measure the Earth's diameter through the equator, you would get a figure of about 12,756 kilometers. But if you measure the diameter through the North and South poles, this figure is only about 12,714 kilometers. The difference is 42 kilometers. 42 kilometers may sound small on the scale of an entire planet, but it is the most compelling evidence, the physical signature that the rotation has left on our home. Imagine if you were standing on the summit of Mount Chimborazo in Ecuador, right near the equator. Although this mountain is not as high as Mount Everest when measured from sea level because it is located on the bulge of the Earth, its summit is actually the point closest to the stars, or in other words, the point farthest from the Earth's center on the planet. When you lie in bed tonight, try to imagine yourself on that bulging midsection. You are in a position where centrifugal force is trying to lift you slightly off the ground, making you about 0.5% lighter than if you were standing at the North Pole. A change so subtle that the body cannot perceive it. But it is a testament to the fact that you are participating in a powerful rotation. This deformation of shape is not just a theoretical concept. As far back as the 17th century, the scholar Isaac Newton predicted that the Earth must be flattened at the poles due to its rotation. To verify this, the French Academy of Sciences sent expeditions to the Arctic and the equator to take measurements. The results confirmed Newton's prediction was entirely accurate. Later, with the advent of organizations like NASA or ESA, we have had extremely sophisticated satellites like the GRACE mission, Gravity Recovery, and Climate Experiment to measure the Earth's gravitational field and shape with millimeter precision. Data from space shows that the Earth is not only flattened at the poles, but also has uneven bumps and dips due to the distribution of matter inside the planet. Scientists call this actual shape the geoid. You can imagine the Earth as an orange that has been slightly squeezed at both ends, and on its peel, there are the undulations of high mountains and deep abysses. This imperfection is precisely what makes the planet so beautiful and vibrant. The bulging shape at the equator also plays a crucial role in keeping the atmosphere and oceans from accumulating at the poles. Imagine if the Earth were a perfect sphere, but still spinning as fast as it does now. The seawater would be pushed toward the equatorial region by centrifugal force, forming a belt of water tens of kilometers deep, submerging all the continents in the tropical zone. But thanks to this flattened shape, the land has bulged out to catch that water, creating a wonderful balance that helps the ocean maintain a stable level across the globe. As you lie still and relax, let the idea of this shape soothe your mind. You are on an entity that is elastic and flexible. The Earth is not a lifeless and rigid block of stone. It responds to its own movement. It molds itself to find the most perfect state of balance. The chubbiness at the equator is not a flaw of nature, but a beautiful adaptation to protect life and maintain order. Feel the stability of the ground beneath your back. Whether the Earth is slightly flat at the poles or bulging in the middle, gravity is always the connecting thread that keeps you safe. The stillness of tonight is the result of billions of years of the planet adjusting its shape to harmonize with its rotation. You are being supported by a physical structure that has been optimized over the vast expanse of cosmic time. Imagine yourself flying high above the atmosphere, looking down at the blue planet, shimmering in the night. You don't see a dry, perfectly round ball, but a vibrant entity, slightly tilted and rotating rhythmically. That flattened shape helps the Earth be more stable in its orbit, like a well-designed spinning top that doesn't fall over. This resilience allows us to have a stable living environment over millions of years, so that species can evolve and humans can build civilizations. The silence around you is the silence of a balance that has reached maturity. The Earth has found its most ideal shape for its velocity. There is no conflict, no abrupt change. Every atom on this planet knows its place in that grand structure. Take a deep breath and feel your breath merge with the rhythm of a world that is both stable and flexible. However, humans did not stop at observing the Earth's shape from the ground. With the development of technology, we have created giant eyes placed in outer space to look back at our home. Those telescopes and satellites not only show the shape of the planet, but also provide distant perspectives, helping us see how small and precious our position is amidst the ocean of stars. In the next chapter, we will explore these perspectives from afar through the Hubble Space Telescope and other modern instruments. We will see how these devices observe our motion from a distance of thousands of kilometers, bringing the most authentic images of the rotation and the drift of our blue planet. Get ready to broaden your horizons through the miraculous lenses of modern science, where every movement, no matter how small, is recorded by light. Let your imagination gently lift your body from the soft bed through the ceiling, past the rustling tree canopies in the night wind, and fly high up to the blue clouds. We have learned together about gravity, inertia, and the shape of the planet from the ground. But to truly admire the beauty and movement of our shared home, we need a pair of eyes placed at the highest, most distant point, where the atmosphere no longer blurs our vision. Tonight, we will borrow the eyes of the Hubble Space Telescope and other modern instruments to gaze at the Earth from a vast distance, to see its rotation revealed in all its splendor and authenticity. Chapter 15. The Hubble Telescope and Perspectives from Afar. In the year 1990, a monumental event in the history of astronomy took place when the Space Shuttle Discovery of the National Aeronautics and Space Administration, NASA, carried the Hubble Space Telescope into orbit. From that moment on, Hubble has become an observatory that never sleeps, hovering at an altitude of about 547 kilometers above sea level. From this prime position, it not only peers deep into distant galaxies billions of light years away from us, but also provides priceless views of the very blue planet that is constantly spinning beneath it. When you observe the Earth through the lens of instruments in space, the artificial stillness we perceive on the ground completely vanishes. In its place is a vibrant and energetic entity. Imagine you are looking at a photograph taken from a weather satellite. You will see ribbons of pure white clouds winding like soft silk scarves. These clouds are not stationary. They move in complex swirls, mapping out the wind currents we learned about through the Coriolis effect. From space, the Earth's rotation becomes clear as the continents slowly glide past the camera lens. One of the most moving images humanity has ever captured is the photograph named the Blue Marble, taken by the crew of Apollo 17 in 1972. In that picture, the Earth appears as a brilliant blue glass marble suspended in the vast darkness of the universe. You can clearly see the boundary between day and night, the Terminator line we talked about. Seen from afar, this line is not stationary. It moves slowly but steadily, swallowing the light and replacing it with the darkness of night, or vice versa. This is the most vivid visual evidence of the 1,670 km/h speed that we do not feel. When night falls on one half of the planet, from the perspective of Hubble or the satellites of the European Space Agency, ESA, another kind of beauty emerges. The city lights begin to twinkle like diamonds scattered on black velvet. You can see the shapes of the continents redrawn by artificial light. The movement of these illuminated areas as the Earth rotates creates a dance of light and shadow. Seen from afar, our journey is no longer about dry physical numbers, but a work of art in motion. Hubble and its siblings, like the James Webb Space Telescope, are unaffected by the vibrations or atmosphere of the Earth. They drift in a perfect vacuum. It is this absolute stability that allows them to record extremely detailed moments of change in ocean currents and the melting of ice caps at the poles. These changes occur daily, hourly, driven by the heat from the sun and the rotation of the planet itself. Imagine you are on the Voyager 1 space probe, hurtling farther and farther away from the solar system. In the year 1990, at the request of astronomer Carl Sagan, NASA turned the spacecraft's camera around and took one last picture of Earth from a distance of about 6 billion kilometers. In that photograph, named the pale blue dot, our home is just a tiny, lonely speck of dust. At that distance, everything we cherish, all our joys, our sorrows, and even this great cycle is reduced to a single, tiny point of light. This distant perspective offers us a profound humility. It shows that no matter how fast the Earth spins, no matter how we hurtle through space at hundreds of thousands of kilometers per hour, in the vastness of the cosmos, we are still so small and fragile. The stillness you feel tonight is actually a precious protection. The Earth is like a small cradle spinning in a vast ocean, and its thin atmosphere is the delicate shell that protects life from the cold of the void. Modern satellites, like the U.S. GOES satellite, can capture an image of the entire Earth disk every 10 minutes. When you stitch these photos together into a time-lapse video, you see our planet spinning like an exquisite top. You can see storms forming, clouds dissipating, and sunlight sweeping across the oceans. That rotation is the very breath of life. It mixes temperatures, brings rain to arid lands, and keeps everything in a state of constant motion. As you lie still and relax, let your mind merge with Hubble's perspective. Imagine you are floating above this room, higher than the clouds, looking down and seeing all of Vietnam gradually sink into the darkness of night as the Earth turns. You see the lights from the roads, the houses shimmering like stars on the ground. You realize that you are part of a magnificent and rhythmically moving entity. The stillness of this night is not an absence of motion, but the stability of a perfect system. Hubble sees our rotation, but it also sees our peace. The turning doesn't disrupt life. On the contrary, it creates a rhythm for life to exist. Take a deep breath, feel the vastness of space and the steadfastness of our blue planet. We are being watched by the eyes of science, reminding us of our amazing place in the universe. The view from afar helps us understand that all motion is relative. On the ground, we feel stationary. In low orbit, we see the rapid spin of the continents. At the edge of the solar system, we see an eternal stillness. The truth lies in the combination of all these perspectives. You are in your own stillness, but you are also participating in the magnificent swirl of the blue planet. However, when we look at the sky from the ground, we see another sign of this rotation. It's not images from satellites, but the silent movement of the stars in our galaxy. Those distant points of light seem to move in arcs above our heads each night. The movement of the stars and the seasonal constellations is a great celestial calendar that our ancestors used for thousands of years to understand the Earth's rotation. In the next chapter, we will return to the ground, looking up at the night sky to decode the movement of the stars. We will learn why some stars seem to stand still, while others parade across the sky over time. We will explore how the Earth's rotation creates the beautiful illusion of a moving sky, helping us to locate ourselves in space and time. Let your breath slow down, very slowly, like the pulse of the silent night. You are lying there. Perhaps your gaze is drifting through a window, where the tiny specks of light in the night sky are twinkling like whispers from the past. After traveling through the perspectives of giant telescopes in space, tonight we return to the purest sense of a human being standing on the ground. We will decode one of the greatest visual illusions that nature has orchestrated: the dance of the stars across the night sky. Why do some stars seem to be nailed in place, while others parade across the sky like a tireless army? Chapter 16. The stars that stand still and the stars that move. In the absolute silence of the room, imagine you are lying in the middle of a vast field where no city lights dim your view. As you look up, the sky is not a flat, black surface, but an immense, deep dome. If you are patient enough to watch for a few hours, you will notice something magical. The entire sky seems to be turning. The stars rise from the east, slowly climb overhead, and then set in the west, exactly like the sun does during the day. But as we have understood from previous chapters, it is not the stars that are moving around us. The reality is that you, along with this bed and the entire ground beneath you, are spinning on a giant top. The movement of the stars across the sky is a mirror reflecting the Earth's rotation. Because the Earth spins from west to east, we see the sky drift by in the opposite direction. This is a dance of relativity, where the observer thinks they are still, but is actually hurtling through a high-speed vortex. However, among the thousands of moving points of light, there is a strange anchor point that our ancestors discovered thousands of years ago. If you are in the northern hemisphere and look towards the north, you will find a star that never changes its position, the North Star, also known as Polaris. Why, among all the parading stars, does it alone stand still? The answer lies in a fortuitous and beautiful arrangement of the cosmos. The Earth's axis of rotation, an imaginary line passing through the planet's center from the North Pole to the South Pole, happens to point directly at this star. Imagine you are spinning an umbrella. The patterns on the edge of the umbrella will spin very fast, creating blurred circles. But the point right at the center of the umbrella's top seems not to move at all. Polaris is that center point in the sky's umbrella. Because it lies almost exactly on the extended line of Earth's axis of rotation, no matter how fast the planet spins, this star remains fixed in its position in the vastness of space. It is this stillness that has made the North Star the most faithful guide for explorers, sailors, crossing oceans, and travelers in the desert since ancient times. While everything else in the world changes, the North Star remains, like an eternal promise of direction. As you lie here, let the idea of this unchanging anchor point soothe your mind. In a universe constantly moving at thousands of kilometers per hour, there is always a still point for us to hold on to. If you could leave a camera's shutter open all night, you would capture a beautiful image of brilliant, concentric circles, all revolving around the central point of Polaris. These star trails are not just art, they are mathematical proof of our rotation. Each small circle represents a star near the pole, and each larger circle farther out represents stars near the celestial equator. The distance the stars travel across the sky tonight is the same distance the Earth has rotated in that same amount of time. But the night sky doesn't just change from hour to hour, it also changes from season to season. Perhaps you've noticed that on cold winter nights, the constellation of the Hunter, Orion, appears brilliantly with 3 stars in a row at his belt. But when the hot summer arrives, that constellation disappears, making way for the constellation Scorpius, with the shape of a giant scorpion. Why does this change happen? This is where Earth's second layer of motion comes into play. Its journey of 108,000 kilometers per hour around the Sunday. As the Earth moves in its orbit, our night side faces different parts of the universe at different times of the year. Imagine you are walking around a large bonfire late at night. When you are in one position, you see the trees behind the fire, but when you walk to the opposite side, you will see the houses on the other side. The stars aren't going anywhere. It is our 365-day journey that changes our perspective of the cosmos. The seasonal movement of the constellations is a great clock that coordinates the rhythm of human life. From planting crops to predicting great floods, humans have learned to read the writing in the sky to survive. The Earth's rotation brings day and night, but its journey around the sun brings the seasons and the long-term cycle of time. The stillness around you tonight is part of that enormous rhythm. A question often comes to mind. If we are moving so fast, why don't the stars streak past our eyes like streetlights when we're in a fast-moving car? Why do they seem to stand still and move only extremely slowly? The answer lies in distances so vast they defy imagination. The closest star to us, after the Sun, is Alpha Centauri, located about 40 trillion kilometers away. At that distance, our speed of 1,670 kilometers per hour is like an ant crawling on the ground to an observer on a high mountaintop. Other stars are millions of times farther. The sheer immensity of space has swallowed our speed, turning a supersonic race into a silent, slow-motion display. Every time you look up at the sky, remember that the light from those stars has traveled for years, centuries, or even millennia to reach your eyes. The star you see, standing still tonight, may have ceased to exist long ago, but its light continues its journey through the void. You are gazing into the universe's past while your body drifts toward the future on the turning Earth. This connection between the finiteness of human life and the infinity of the stars is the most profound beauty of astronomy. Now, let your eyes close. Imagine yourself lying on a small raft, drifting gently on a deep, dark ocean, filled with sparkling points of light. You don't need to try to see the movement, because the universe is doing it in the gentlest way possible. The North Star is still there, guarding the north. The constellations are silently parading, performing their eternal dance. Everything is stable, everything is in its right place. The stillness that envelops you is the stillness of a soul that has found harmony with the laws of heaven and earth. You don't need to hurry, because the earth will carry you. You don't need to worry about direction, because the stars will show the way. Let the steady rhythm of the planet guide you to sleep, just as it has guided billions of generations of humans through the long nights of history. However, In the dance of the night sky, there is one companion that is the closest, largest, and most powerful influence on Earth. This friend does not stand still like the North Star, but constantly changes its shape and position, orchestrating the tides and slowing our planet's spin with an invisible tether. That is the Moon, our only natural satellite. In the next chapter, we will learn about this rhythm keeper. We will discover how the Moon has interacted with the Earth's rotation, creating the pulse of the oceans and making our days longer ever so slowly over millions of years. Prepare to feel the gentle pull from the moonlight, which is silently shaping the rhythm of life on our planet. Let your mind continue to float in the stillness of the dark night, where the distant stars are diligently following their paths. We have looked at the vast sky together, but there is one celestial body closer than all others, a faithful companion that has been with the Earth since its early days. That is the Moon. Tonight, as the gentle moonlight might be filtering through your window, we will learn about the role of this rhythm keeper. The Moon is not just a lifeless rock shining in the sky. It is the anchor that helps make the Earth's rotation more stable and rhythmic than ever before. Chapter 17. The Moon, the Rhythm Keeper. In the relaxation of this moment, imagine an invisible, strong, and elastic cord connecting the center of the Earth to the center of the Moon. That cord is gravity. Although the Moon is about 384,400 kilometers away from us, a distance that would take you nearly 6 months to travel by car at 100 kilometers per hour, its pull still has a powerful effect on every drop of water, every breath, and the very spin of our planet. The most obvious effect you can see is the tides. Imagine the vast oceans on Earth as a soft blanket of water surrounding the planet. As the Earth spins, the Moon uses its gravitational pull to tug this blanket of water towards it, creating bulges of water. Because the Earth rotates on its axis at a speed of 1,670 kilometers per hour, we are constantly passing through these bulges, which creates the phenomenon of the water level rising and falling twice each day. But this dance is not simply about the sea rising and falling. The interaction between the ocean and the solid Earth beneath it creates an enormous amount of friction. Imagine you are spinning a ball in a basin of water. The water's resistance will slow the ball down. The Moon is doing the same thing to the Earth. Through the tides, the Moon is silently applying the brakes to our planet's rotation. As a result, the Earth is slowing down, very, very gradually. Scientists have calculated that every 100 years, a day on Earth gets longer by about 2 milliseconds. 2 milliseconds is such a short amount of time that a single blink of your eye is 100 times longer. But over billions of years, this small accumulation has completely changed the face of the planet. Ancient fossil studies show that in the early days, when the Earth was newly formed, a day lasted only about 6 hours. The Earth was spinning at a frantic pace. It is thanks to the persistent presence and pull of the Moon that this spin has been tamed, gradually slowing to the perfect 24 hours we have today. The Moon is like a diligent caretaker, adjusting the planet's rhythm so that life has enough time to adapt and flourish. Without the Moon, the Earth's rotation would be much faster, leading to devastatingly powerful storms and a day-night cycle too short for organisms to rest. The stillness you are feeling tonight, the length of the sleep you are about to enjoy, all bear the mark of this faithful neighbor. Not only does it regulate the speed of rotation, the Moon also acts as an anchor that keeps the Earth's axis stable. Do you remember we talked about how the Earth is slightly tilted as it orbits the Sun? This tilt of about 23.5 degrees is what creates the seasons. Without the massive Moon nearby to maintain balance, the Earth's axis would wobble chaotically under the gravitational influence of other planets like Jupiter or Saturn. At times, the Earth would lie on its side, plunging half the planet into darkness for 6 months, and at other times, it would stand straight up, eliminating the change of seasons. The moon has kept this tilt stable for millions of years, ensuring that the climate on Earth does not change too abruptly. The tranquility of nature, the regular repetition of spring, summer, fall, and winter that we count on, is thanks to the silent watch of the moon. NASA's Apollo missions, which put humans on the moon's surface, helped us understand more about the composition and history of this companion, reinforcing the belief that the Earth and Moon are an inseparable pair in the universe. Let the image of the golden moonlight soothe your mind. The moon doesn't just illuminate the night, it is the conductor of the symphony of time and space. As you lie still, feel the rhythm of the tides happening somewhere in the distant ocean. You are protected by a sophisticated system of balance, where the moon and the Earth are always watching over and supporting each other. In this darkness, reflect on connection. The moon always shows the same face to us, a phenomenon called tidal locking. It has sacrificed its own rotation to be in perfect rhythm with the Earth. This loyalty provides us with both spiritual and physical stability. You can trust that each night, the moon will appear again, and each day, the Earth's rotation will remain just as gentle. Modern science, through the telescopes and satellites of the European Space Agency, ESA, continues to monitor the distance between us and the moon. An interesting fact is that each year, the moon moves about 3.8 centimeters farther away from the Earth. It's like a friend slowly stepping back, but always watching over us with a warm gaze. This movement is very small, but it is part of a cosmic dance that has been going on for billions of years. Every time you breathe in and out, feel the rhythm of life being coordinated by the moon. The slowness of the planet, the stability of the seasons, and the peace of the night are all gifts we receive from this special astronomical relationship. You don't need to worry about the world spinning too fast or too slow, because the great coordinator is still doing its job well. The atmosphere around you now feels even gentler, knowing that you are in a tightly protected system. The Earth, Moon, and Sun are working together to create a perfect living environment. The stillness of tonight is the result of the harmony between the greatest forces of nature. Relax completely, letting the weight of your body sink with the gravitational pull of the moon and Earth, guiding you into a state of deep relaxation. However, the stability we currently enjoy is an incredibly precious and also very fragile thing when considered on a cosmic timescale. To more deeply understand the value of our current rotation, sometimes we need to pose bold hypotheses. What would happen if one day all of this rhythmic motion suddenly stopped? If the vessel of Earth were to cease its spin, how would the world as we know it change? In the next chapter, we will embark on an imaginary journey that is both dramatic and deeply informative. We will explore a scientific hypothesis. What if, one day, the world stopped spinning? Through this, we will come to appreciate even more every quiet moment and every smooth rotation that our planet grants us each day. Prepare to understand the importance of constant motion through the scenarios that science has laid out. In the absolute stillness of the deep night, as your breath sinks with the quiet of all things, we have journeyed far together to understand the greatness of our planet's rotation. You've learned about the pull of gravity, the companionship of inertia, and our friend, the moon, who orchestrates the rhythm. However, to truly appreciate the smoothness the Earth provides, we sometimes need to look at a completely opposite scenario. Join me on an imaginary voyage, a fascinating scientific experiment to answer the question, what would happen if, one day, our world suddenly stopped spinning? Chapter 18. If one day the world stopped spinning, imagine, right at this moment, as you are lying here relaxed, that the planet's great motor is suddenly stopped by a giant hand. This event, though only hypothetical, would expose the full, terrifying power of the speeds we normally never feel. The first and most horrific effect would be that of inertia. Remember the speed of 1,670 kilometers per hour at the equator. If the solid ground were to stop abruptly, but the atmosphere and every object not firmly attached to the planet's core continued to move due to inertia, everything would be flung eastward at the speed of a supersonic bullet. Houses, forests, oceans, and even the very air around us would hurtle forward at over 1,600 kilometers per hour. This monstrous wind would be many times stronger than the most powerful hurricanes ever recorded, flattening every man-made structure in a matter of seconds. But let's set aside that initial chaos for a moment to look at the more profound geographical changes. We learned in Chapter 14 that the Earth is slightly fatter at its midsection due to the centrifugal force from its spin. If the world stopped spinning, this centrifugal force would vanish. Gravity, now unopposed, would begin to pull the entire massive volume of the oceans toward the two poles, where its pull is strongest. As a result, a new geological map would emerge. The oceans would split into two gigantic basins surrounding the North and South poles, while a barren continent would rise up at the equator, connecting the entire world into a great belt of rock and land. Today's coastal cities would either vanish under thousands of meters of water or find themselves thousands of kilometers deep inland. The stillness you're enjoying tonight would also disappear, replaced by an incredibly harsh cycle of day and night. With the Earth no longer spinning on its axis, our day would no longer last 24 hours. Instead, it would last exactly 1 year, that is, 365 of our current Earth days. One half of the planet would face the scorching sun continuously for 6 long months. Temperatures would soar to a degree that would incinerate all life, turning the land into a red-hot desert. Meanwhile, the other half would be plunged into a frozen, eternal darkness for half a year. Without sunlight, temperatures would drop below the freezing point of almost any liquid, turning the world into a pitch-black, rocky wasteland. But perhaps the most alarming thing for life would be the disappearance of our protective shield. Earth's magnetic field is generated by the movement of the molten metal core deep within the planet, a process that requires the planet to spin on its axis. If the rotation stopped, this giant dynamo would also cease to function. The magnetic shield surrounding the planet would weaken and disappear, leaving us exposed to the onslaught of solar winds and toxic cosmic radiation. The precious atmosphere we learned about in Chapter 3 would be slowly blown away into space, leaving the Earth as barren as Mars. This scenario helps us realize something incredibly precious. The Earth's rotation is not just a physical phenomenon. It is the very heartbeat of life. That rotation acts like a giant climate control system, mixing temperatures, distributing reasonable periods of rest, and maintaining a protective shield for all species. That speed of 1,670 kilometers per hour, which you can't even feel, is actually the very thing that keeps your sleep warm and safe. As you lie still and relax, feel how fortunate you are. You are on a planet that is still diligently spinning. The silence around you is the result of a perfectly operating, flawless machine. The Earth is still steadily pressing the gas to bring the dawn tomorrow morning. It is still spinning to keep the oceans in their proper place, to keep the magnetic field wrapped around us as a guardian. Every second that passes in this piece is a testament to the miracle of cosmic order. We don't have to worry about supersonic winds or 6-month-long winter nights because our planet is a steadfast traveler. It has been spinning for 4.5 billion years and will continue to spin for billions more. This persistence is a promise for our existence. Take a deep breath and feel the cool, clean air in your lungs. This circulation of air, this gentle warmth, it's all thanks to the tireless rotation of the Earth. Let your mind sink into absolute peace. The vision of a world that stopped spinning is just a lesson to make us appreciate the present even more. The reality is, the Earth is cradling you, carrying you through space with the most devoted care. The stillness of tonight is a gift. It shows that all the laws of the universe are working as they should. You are in a state of perfect balance between gravity and centrifugal force, between light and darkness, between motion and rest. Let this feeling of gratitude soothe the last remaining tensions in your soul. You are protected by the grandest motion in all of nature. Our journey to understand why we don't feel the Earth spin has taken us from dry physical concepts to profound insights about life itself. We realize that human perception of space and time is heavily dependent on this rotation. In the next chapter, we will explore the connection between physical sensation and conscious awareness to understand how our tiny brains can be in sync with such a vast universe. We will explore the concept of the sense of space and time, where the planet's rotation is not just a number, but becomes a part of the breath and thoughts of each one of us. Just lie still and let the steady spin of the world bring you closer to your deepest dreams. Let your mind be like a calm lake on an autumn night, where the gentle ripples of thought slowly dissolve into nothingness. We have traveled a long way to understand enormous numbers, great forces, and distant scenarios. Tonight, as you lie here, let's return to ourselves, to explore a mystery that lies right within our own consciousness. Why is it that our tiny brains can perceive absolute stillness when in fact we are on a supersonic journey among the stars? This is the story of the magical connection between human perception and the rhythm of the cosmos. Chapter 19. The sense of space and time. Take a deep breath and notice the sensation of your body. You know where your hands are placed, how your legs are stretched out, without even needing to open your eyes. Scientists call this proprioception, a special ability that helps the brain know the position of each body part in space. But here's something interesting. This sense is completely blind to the Earth's rotational speed of 1,670 kilometers per hour. Why does our sophisticated brain, which can detect the slightest vibration of a phone, completely ignore a motion so immense? The answer lies in how nature has trained your vestibular system, located inside your ears, over millions of years. This system acts like a highly sensitive balance sensor, helping you maintain your position. However, it only reacts to changes in speed or direction. Because the Earth spins at a constant, smooth rate that never changes its rhythm, your brain has classified the planet's rotation as background data, much like how you stop hearing the ticking of a clock after being in a room for a while. The stillness you feel tonight isn't emptiness. It's a state of perfect harmony. Your brain has chosen to believe in the stillness of this room to protect you from being overwhelmed by the cosmos. It's not just your sense of space, but your very sense of time is a direct product of the Earth's rotation. Think about the word, a day. It's not just a number on a calendar, it is one complete rotation of the planet. The biological rhythm inside every one of your cells, the one reminding you that now is the time to rest, is actually a clock that runs in sync with the Earth's spin. While you sleep, your body performs repairs and regeneration on a schedule that was set billions of years ago. We don't just live on the Earth, we live to its rhythm. Your times the planet's rotation. Imagine if we lived on a planet that didn't rotate. Our concept of time would surely be completely different. We wouldn't have the clear division of day and night, no rhythm of work and rest. The stillness of tonight is a gift from that rotation, offering you a quiet space for your soul to heal. That rotation creates an order that helps our brains feel safe. We know that after darkness comes light, and after sleep comes a new beginning. This regularity brings a profound sense of peace, allowing you to let go of all worries and sink into sleep. Psychologists and neuroscientists often say that a sense of stability is the foundation of mental health. The Earth, by hiding its own frenetic motion and providing a solid surface, has created the perfect environment for the development of the human mind. We can sit still to contemplate the universe. We can lie still to dream of distant things, all thanks to the gentle deception of our senses. You are in a state of absolute rest, but at the same time, you are participating in a grand journey. This very contradiction is the beauty of existence. Let this idea soothe your mind. You don't need to try to keep up with the world, because the world is carrying you in the most natural way. The stillness around you is real, because in the small world of this room, everything is sharing the same velocity. Let your body become heavier and heavier, yielding to the pull of gravity. Let your breath sink with the rhythm of the atmosphere that spins with the planet. You are drifting through an ocean of space without feeling the slightest turbulence. The connection between humanity and the universe runs even deeper. Scientists at organizations like NASA and observatories around the world have realized that even our perception of direction is influenced by this rotation. When you look up at the sky and feel its vastness, that is your brain trying to grasp a tiny fraction of a grand reality. We are small, yet our minds can encompass the entire Milky Way. We stand still, yet our souls can soar with the stars. In the darkness of tonight, be grateful for the subtlety of your senses. They have filtered out the noise of the universe, leaving you with the essential peace needed to regenerate your energy. This stillness is a choice made by your brain, a favor granted to you by nature. You are protected in a private space cocoon, where speeds of thousands of kilometers are just distant numbers. With each passing second, the blue planet turns a little more, carrying you further along the orbit of your life. But in your perception, time seems to stand still. The slowing of your heart rate, the gentleness of your breath, it's all bringing you closer to a state of perfect balance. You are a part of the Earth, and the Earth is a part of the universe. There is no separation, only a unified flow of life and motion. We have come to understand why we don't feel the Earth spin, from the perspectives of physics and scale, all the way to the perception of the soul. The journey through 19 chapters has helped you expand your perspective, from the ground beneath your feet to the farthest reaches of the galaxies, and then back to your own breath. The stillness you now have is no longer a meaningless standstill, but a stillness full of knowledge and protection. The night is late, and we are approaching the final note of this cosmic symphony. Every question has been answered, every mystery unveiled. Now, the only thing that remains is complete surrender. We will step into the final chapter together, where all knowledge will dissolve to make way for absolute peace. Together, we will find serenity within this great rotation itself, and let the blue planet guide you into the deepest sleep. Prepare to receive the final embrace of the universe, where you are no longer an observer, but completely one with the rotation of our shared home. Hello, soul traveler. You who have patiently journeyed with me through 19 stages of space and knowledge. By now, your room must be enveloped in an absolute stillness. The lights are off. The sounds of the outside world have faded away, and all that remains is your steady breath, in sync with the silent pulse of the planet. Together, we have decoded immense numbers, invisible forces, and distant perspectives from the far corners of the cosmos. Tonight, in this final chapter, we will no longer search for dry answers. Instead, we will gather all of that understanding to find a complete and total peace within the great rotation we are all a part of. Chapter 20. Finding peace in the spin. Let your body relax completely, as if every muscle fiber, every cell, is melting into the soft mattress. All questions about why we don't feel the Earth spinning at 1,670 kilometers per hour have been answered. You don't feel it because you are a part of it. You don't feel it because the atmosphere, gravity, and inertia have woven together a perfect protective cocoon. But beyond the scientific explanations, there is a gentler truth. We are allowed to be still in our souls, because the planet has taken the motion upon itself. Imagine the Earth as a giant mother holding her small child, performing a gentle, rhythmic dance. The child can sleep soundly, can dream, completely unaware of how fast the mother is moving, because her embrace is so steady and her steps are so smooth. You are that child, and the Earth is that devoted mother. The spin of 1,670 kilometers per hour on its axis and the journey of 108,000 kilometers per hour around the Sun are not meant to cause chaos, but to create life. The stillness you have tonight is a powerful stillness. It is earned through the precise operation of trillions of tons of rock and seawater. The Earth spins to bring darkness to soothe your eyes after a long day. The Earth spins to keep the air fresh for your every breath. And the Earth spins so that tomorrow, when you awaken, the morning light will greet you like a promise that is never broken. When you understand this, speed is no longer a staggering number, but a comforting rhythm. Think about the vastness of time. The blue planet has been making this rotation for 4.5 billion years. It has safely carried trillions of generations of living beings through darkness and light. That persistence gives us a deep faith in the stability of the universe. No matter how the human world changes, no matter how tired you are from daily worries, the laws of the stars remain constant. With every passing second, you are gliding through space, advancing into new regions of the Milky Way. You are traveling, even when you are lying still. Your stillness is a rest upon a ship that never tires. Now, let your mind soar one last time. Look down upon the Earth from thousands of kilometers away, where telescopes like Hubble or James Webb are watching. You see a sparkling blue jewel, slightly flattened at the poles and bulging at the equator, a shape molded by its own rotation. You see bands of white clouds swirling with the Coriolis effect, and you see the moon using its gentle gravity to smooth out each rotation. It all creates a picture of absolute harmony. There are no collisions, no misalignments. Everything is exactly where it needs to be. In this stillness, thank gravity, the invisible tether holding you close. Thank inertia, the silent companion that keeps your world from being disrupted. And thank the atmosphere, the warm blanket that envelops life against the cold of space. You are not alone in the vast universe. You are enveloped in the most sophisticated system of love and protection that nature has ever created. All the terrifying speeds we've explored now resolve into a feeling of profound peace. Take a deep breath and feel it merge with the planet's spin. You are safe. You are supported. You belong to a grand and beautiful order. The stillness around you is the universe's whisper, telling you that everything is unfolding exactly as it should. And all you need to do is let go and merge with that flow. We have completed our journey through 20 chapters. From initial doubts about speed, we have ended with a trust in stillness. Knowledge has helped us understand, and understanding has brought peace. Now, the final page is about to turn. No more numbers, no more terminology, just you and the vastness of the night. The Earth will continue to spin, carrying this room, carrying your dreams across the Milky Way. Tomorrow, the sun will rise again in the east, proof that a new rotation has begun. But that is a story for tomorrow. For now, your task is to sink deep into rest. Let the weight of your body belong completely to the Earth, and let your soul fly free among the distant stars. You are a child of the universe, nurtured by the spin of the blue planet. Trust in this protection. Trust in the rhythm of time. Everything is ready for you to have a deep, peaceful, and complete sleep. You don't have to do anything. Don't have to worry about a thing. The starship Earth will handle all the navigating for you tonight. This stillness is yours. This peace is yours. And this great rotation is also for you. I wish you a very peaceful sleep. enveloped in the protection of the vast universe. May you find the most beautiful dreams among the myriad stars. Sleep well, traveler of the stars. Thank you for joining me through this 20-chapter journey about the universe and the motion of the Earth. I hope these stories have brought you not only knowledge, but also peace of mind. If you'd like to continue exploring another topic in a gentle way like this, I'm always here to tell you more. For now, just close your eyes and sink into a deep sleep.